Righto, we are live now. Sorry about the delay, people, but it wasn't really technical issues, but talking issues. Righto, we are live now. Sorry about the delay, people, shit. But there's a technical issue. It wasn't really technical issues, but talking issues. Righto, we are live. Yeah, okay. Sorry about that. We did have a technical issue. Me. It seems to be me all the time that has this technical issue. Now, just before we went live, we thought we'd try to delve into a little bit of this again because it seems that not everybody, but some people seem to have a bit of not a misunderstanding, but it's hard to explain pressure gradients
A miscommunication.
with our atmosphere, which we're going to be direct in the explanation instead of trying to use all these other analogies all the time for other pressure systems without a container and all this sort of stuff. I've got an experiment that we're going to show here, which is shit. So I've forgotten it already. Hexafluoride something.
Hyperfluoron.
Oh dear. And wait, and you just can talk over it because there's no the only sound you'll hear is hissing. It's a hissing sound. Now this is obviously a gas. I don't know if it's a where the gas comes from. It comes out of the bottle.
Does it? What's that silver thing? A brick wrapped in foil.
What do you think it is, Vandy?
I've got no idea.
It's
Yeah,
flimsy. It's flimsy and it's shaped like
Oh,
a boat such shape.
it looks like tin foil.
You wrap your fish in it, mate.
Aluminium foil.
Uh,
And it seems to be suspending itself in midair by itself.
ah,
But
Why
he's
is it so?
obviously he's putting some sort of element into into that bottom of the container through that hose, out of a pressurized container next to it with that regulator valves that are on top. So would you class that? I'd say it's a gas that he's putting into that fish tank type container.
Mm.
It's heavier
Then the air inside that
than
foil
the
container.
air around us, or the air
Yes.
above it. Yeah.
Yeah. So what is it? LPG or something?
No, Davros knew what it was. I can't remember what.
Sulfur hexafluoride.
Sulfur hexafluoride. There we go.
Yeah.
Now this is partially to explain how gases can be in different layers, like in our atmosphere, how we have different pressure gradients. But to me, it shows that visually, if similar to how we are on Earth, how we got the 14 psi closer to the sea level, I suppose. As you go up in the atmosphere, have less pressure. That's all because of the G word as well.
Well, it looks more buoyant.
Well, it's a pressure gradient. It's the layer of gas is heavier than air, and because of its mass, gravity's able to contain it lower to the ground because it's a denser gas. Now, obviously, someone with a bit more expertise in the pressure gradient explanation, how we can relate this to our atmosphere's pressure gradient. What?
Yeah, what? What do you mean? Okay, so this isn't explaining a gradient. Basically, it's explaining that you can have gas in what's classified as a well, it's an open top container. if you see, by adding extra molecules into the aluminium boat, you're increasing the density of the gas in the boat, which makes it sink into the lower density of the extra gas in the container. So all they've done is put extra gas of the same product into the container, and it's sunk in the same medium.
Yeah, well, it's the same. Yeah, they've just replaced the air with the same gas, haven't they?
Yeah, but it was floating in the same gas. All they've done is increase the amount of gas in the container. And what they've just done there is pick it up, empty the gas out,
Yeah.
and then it floats again.
Yeah, but they fill the container with the gas.
Yeah, but look, it's like water. They put that container in, and it floats up.
Yeah.
Yeah. And now, watch this.
It's crazy. It's like magic, isn't it?
Hey, it's white man magic.
That's woo. That is woo.
How's it woo?
Look at it.
Not healing you.
That is pretty wooey. Come on.
It's not saying it's healing you, though. Hasn't got its chakras out.
But
Sounds like someone's nailing lemons to the wall.
But to me, it's a good way of representing visually of how a pressure gradient would be visualised in our system. How we've got more pressure at the sea level compared to as you go up higher.
Yeah.
That's
but
the
when
way
you don't have,
that's the way I looked at it.
When you have weather systems not blowing the gases around and they all mix up, you don't quite get that. But then at a certain altitude, you do get that, don't you, Paul?
Where do get what?
You get where the gases kind of separate themselves at a certain altitude.
Or
am I wrong there?
It only happens at extreme altitudes.
Yeah.
Typically what happens is each gas in the atmosphere, like oxygen, nitrogen, carbon dioxide, or whatever, each individual gas has what's called its own scale height. The scale height is a number which describes how high you have to go before the pressure is a certain amount of times less than the pressure at sea level. And that height is different for different gases in the atmosphere because different gases have different molecular masses or different atomic masses. So, for instance, one gas like carbon dioxide is much heavier than oxygen. And so it has a different scale height in the atmosphere. But each individual gas with its own individual scale height, they all overlap. So you've got to add up and overlap the scale heights for each gas and average them out. And so it turns out that when you do that the mixing of the gases in the atmosphere, you end up with roughly the same composition all the way throughout the atmosphere as elevation increases, except right at the very, very top, where the scale height of really, really light gases like helium and hydrogen is extremely high.
Mm-hmm.
And so they tend to predominantly occur at the more alone in higher concentrations at the very top of the atmosphere because they've got the energy, the speed, because they're really light molecules and atoms. They've got the kinetic energy to get right up there.
Do you get the same and is that with the argon and the neon too, Paul?
Not so much, no.
Right, okay.
No.
So Paul, me using this, it's a bit obscure, the representation of using this, the gas that they're using here is the heavier gas. Representation of what you're saying for the lighter gases up. Like you could just reverse this image and visualize that the lighter gases are up above that metal aluminium floating up higher.
Yeah. I mean, there obviously is a pressure gradient within that tank because otherwise the boat wouldn't float on it like that. Buoyancy is something that's caused literally by a pressure gradient. You have to have a pressure gradient to have buoyancy. And so that boat floating on top of the denser gas shows that there is actually a pressure gradient there, because you can't have buoyancy without a pressure gradient.
No.
Anytime you see something floating, there is a pressure gradient. So Terry's right, that demonstration literally does show in a roundabout way. You have to understand the physics of it.
Yeah.
It does show in a roundabout way that there is a pressure gradient within that tank.
Like our atmosphere, the heavier the 14 psi is because of mass. Is it the mass of the air? It's because gravity is pulling it closer to,
Yeah.
to near the ground
Yeah.
level. And as you go up higher, there's less forces on the air, less forces of gravity pulling on the air molecules as you get higher and higher.
Yeah. I mean, everybody knows that if you put a ping pong ball into a glass of water, the ping pong ball's going to do what, Bandy?
Well, it floats, doesn't it?
Yeah, exactly. It's pretty obvious, isn't it? Everyone's intuition knows that. It floats on top because it's far less dense overall than the water, and so it doesn't take much of a it doesn't take much displacement of water. The ping pong ball doesn't have to displace much water to create the buoyancy force enough to make it float. But if you were to take that same glass of water and do the same experiment in the ISS, what do you think would happen?
Yeah.
What do you think would happen if you were to put that ping pong ball in the glass of water on the ISS?
Well, I'm going to say that it goes to the bottom, but I want to say it floats.
I was just going to say I'd never see how you could get a ping pong ball to actually float in a glass of water in the ISS. That'd be my first thing.
Yeah, what would your prediction be,
glass.
Terry?
The water, because of its capillary action and how it adheres to itself, it forms its own sphere in gravity. No gravity.
All right, so
the ping pong ball would just get enveloped by the water.
Yeah, exactly. That's exactly right. So there is no buoyancy there on the ISS. There's no buoyancy. There's no pressure gradient there.
So technically, it floats in the sphere of water.
Yeah. I mean, like if you were to release a helium balloon on the ISS, what do you think would happen?
I know. But Bandy can answer.
It drops.
No.
No.
It doesn't drop. No.
It just stays there.
Well,
Exactly.
Which vector would it go, Victor?
No vector.
Have we got a that ping pong ball experiment in the ISS? Have they done that one?
Well, you could actually copy it by what happened with the bloke. He squeezed a rag of water with all water
wrapped
in it,
around his hands.
The water just enveloped his hands. So that'd be like the ping pong ball would have got enveloped with the water as well.
Well, a similar sort of concept is bubbles in water. Like, what do you think happens to the bubbles if you have water with bubbles in it? Here on Earth, what happens? The bubbles rise to the top because they're less dense. There's a pressure gradient in the water. The water bubbles, the air bubbles displace water, creating buoyancy. Because there is a pressure gradient, they rise. But on the ISS, there is no pressure gradient in the water. And so it would, the bubbles would just stay where they are.
Yeah,
How can there be no pressure gradient?
Because there's they're weightless. Because everything's accelerating at the same rate towards the Earth. It means that there's no weight force.
But isn't gravity still affecting the ISS?
Yeah. Gravity's still affecting them.
Yeah.
The thing is that everything's accelerating at the same rate towards the Earth. And so it's like being in an elevator that's in free fall.
Yeah.
Okay?
Yeah.
the elevator, you're dropping towards the earth, but the elevator's dropping at the same rate as you, and so you're not getting any closer to the
floor.
To the floor. It's exactly the same with the ISS going around. Okay, you're getting pulled towards the earth, but so is the ISS. But it's just got such a high horizontal velocity that as it gets pulled closer to the Earth, it shoots sideways, and the curvature of the Earth drops away underneath it, and it never actually physically gets any closer to the Earth.
And they're in permanent free fall.
Yeah, that's right. Yeah, and so there's no buoyancy on the ISS.
Yeah, there's nothing to act against it, Bandy.
Yeah, so that sulfur hexafluoride experiment would not work on the ISS. No. You would not be able to get the stuff to stay in the container, and you wouldn't be able to get the boat to float on it.
Look, I get the theory, I do.
Yeah.
I do, but I don't know. It's above my pay grade.
It's well above my pay grade, Bandy.
Actually, I don't know. Actually, how much do astronauts get paid these days?
I don't know.
It might be below my pay grade. I don't know.
I'm not going to divulge the amount I get paid for my shield checks.
Yeah, well, tell your manager he needs to bloody well post mine.
Oh, you have to believe in the globe before you get a shield check.
No, you don't.
Yeah, you do, because all the globers are shields.
Bandy's got to get his controlled opposition check.
Well, you better speak to the Illuminati about that one.
The Illuminati, the Freemasons.
No. Freemasons are on our side, mate.
Are they? Yeah, but I've got to infiltrate them. That's the plan of attack. I've got to get to, what is it, the 33rd?
3
degree or arc?
Just 3. Just 3.
Just 3?
Yeah.
Is that the one where the microphone disappears through his hand?
No, this is the one where he's going to pour out water. He's going to show you what happens to water.
Yeah, actually, that's something funny how they all.
Yeah, where's the harness holding that cloth?
Yeah, where's the strings holding the microphone in place?
He's on the vomit comet.
Yeah. If he was on the vomit comet, do you know that all those cables around him would actually be moving? All those electrical cables would actually be moving up and down.
Oh, okay. Sorry, I take it back. It's a studio in Hollywood. I'm looking for.
Look how he gets that water to go horizontal like that.
Yeah, horizontal water. I see horizontal water when we get a storm.
Well, it didn't find its level.
This is freaky, this bit. Yeah.
Squeezy.
How the water just... Oh,
look,
so weird.
Look, it's enveloped his fingers.
Oh,
it's like jelly.
Yeah, it's weird. Look at it. That's so weird.
It's not weird, it's awesome.
Okay, then.
Yeah.
Paul, what holds all that water together?
Surface tension.
Yeah.
There are attractive forces between the water molecules.
Okay, so it's only surface tension that's keeping that all together.
Yeah, and also the capillary action on his hands is what's making it stick to his fingers.
Well, that's what surface tension is all about.
Yeah.
Losing drops of water.
Look at his watch. That looks a bit dodgy.
Because it's floating, Bandy.
Casual spaceman.
I'm looking.
He's lurking out in the side chat.
No, is he?
The casual space race.
Okay. What happens if they light up as smoke? Where's the smoke going to go?
They wouldn't light up one.
Oh, what is it? A smoke-free zone?
Yeah.
It's also the fact that it's got a slightly higher oxygen content in there.
A smoke-free workplace.
It might go boom.
No. How can it go boom?
Because it's got a higher amount of oxygen in the atmosphere in the ISS compared to what we have down
No,
here.
I think they've got the same composition in the ISS.
Yeah, they have to, wouldn't they?
Oh, see, I don't think they've got like all the little other molecules. The only thing I think they've got is the nitrogen and the oxygen.
Yeah, well, that comprises about 99% of air anyway.
Mm.
They'd have heaps of stuff. They'd have carbon dioxide. They'd have everything.
Yeah, there'd have to be some carbon dioxide there.
Exactly.
Yeah, that comes from them.
That's right.
Yeah. And then gets scrubbed and recycled.
What about all the off gases too?
Oh, look out.
Caused
Here comes the fart joke.
Here comes.
Yeah. Yeah. You're telling me they don't fart on the ISS?
Yeah, no, but all the off gases from all the plastic,
Here comes the fart
metal,
joke.
and everything as well.
You're telling me they don't fart on the ISS?
Yeah, no, but all the
Spaceman.
echo.
Like
Mute your watch,
the
mate.
YouTubes.
I fixed him.
The off gases from what? From the cables and the computers and stuff.
Yeah, off gas. Yeah, 100%. That's a thing. Damn.
I fart in space all the time. It's okay.
Everything produces gas. Off gas.
I'm trying to find Bandy some good water stuff from the ISS.
Yeah. I'm just going to ask Bandy a question. Do you not think that all the stuff they would put on the ISS, they would try to make it out of materials that do the least amount of off-gassing?
That's neither here nor there.
It's called outgassing.
Or outgassing, but it's neither here nor there whether or not they use products that cause the least. I'm just saying that plus there's all the off-gassing.
How'd we get from air pressure to water in space?
It's my fault, it must be.
I have to go back. Okay, where's the secretary? He hasn't come back yet.
But Bandy, I'm going to do your trick here. Okay, you say that there's a whole heap of off-gassing up there.
No. I said we were talking about oxygen and nitrogen and a bit of carbon dioxide, and I said plus the off gases from all the bits and pieces.
But what are the off gases?
Well, I don't know what they are, but everything produces off gases, all plastics and materials and stuff.
What about steel?
That I'm not too sure, but I would say yes.
How does steel off gas
Just
or
through,
out gas?
just through degradation.
But what's up there to rust it or cause oxidization?
What do you mean? What's up there? Moisture.
Where?
What do you mean? Where?
I think it's a bit of a pointless argument anyway, because any outgassing that happens is going to be such a minute compositional part of the atmosphere that's there. You really wouldn't be able to worry about it.
No, I didn't mention it as a point of contention there.
There's a link to another video with water in zero gravity, or sorry, microgravity, in this side chat. It should be there anyway. Another really good example. Go to about 105.
Oh, it's because that's where we miss you.
Yeah. No, a bit tiny bit further. No, bit further. There you go. That'll do.
Around near there. Yeah. I was going to use that one. That was on the list I was going to get.
There you go. Play.
I've seen that one on the list. I was going to grab that one. It's how they drink water. Oh no, I think this is the one where how they drink water.
No.
Oh, okay, it's a different one.
Always talking about water not conforming to a ball. Well, this one is a ball.
Yeah, I think that's a bit of an unfair comparison, though. Why doesn't he get a ball and wrap that water around it? Would it stick to the outside of it?
Did he blow air in it?
There you go.
Did he blow air into it?
Yeah, he just blow. Yeah, he did. Yeah, yeah. If you notice, he's noticed before he did that, it was his image, the reflection through it, the refraction, I should say, through it was upside down. But now he's put the air in it. He's up the right way. You notice that?
I noticed it got bigger too.
Yeah. I wonder why that is.
Ether band.
There you go. That was it. It's quite
Well,
quick.
we're talking about pressure in the vacuum, pressure gradient atmosphere stuff, and we got onto water in space.
Yep.
Oh, okay. Well, I can't find anything else to represent
It's a natural
atmospheric
progression.
pressure. Have a look. See if I can find this other one. I don't know who did.
Oh, here's a crazy one for you. I'll link it in Discord. I'll just stick it in fair suck. It's Alka-Seltzer in a sphere of water in microgravity.
Oh, okay. Then I'll look for the one I was looking for. Where have I got to go back to Discord?
Yeah, it's just in fair suck.
Yeah, I
Just
see
because
it.
it's
Yeah, I see
quicker.
it. Yeah, I got it.
Where's Laurie?
Because this will show you how you can actually have a denser chemical inside the water.
Demon Orb's not as flatty, is he?
No.
Oh, because he says, I'd like to see a globe.
Yeah, I tried
to.
I tried, but there isn't any video of one.
No, that's what I just said before, wasn't it?
Yeah, but this is awesome.
Playing?
Oh, I'm dying.
That's okay. We'll let you.
Well, you better lay down then.
I am laying down. How do you know I'm not laying down already? I am laying down, in fact. No, I'm not. I'll lay down when I'm dead.
Oh, okay.
Are you playing this, Terry?
I don't know.
No, it's like
I've got pause, but the red thing's moving.
No, no, it's not.
Oh, there we
It's
go.
still. Oh, it's moving now. Yeah.
Yeah,
It is moving. This must be in
it is.
slow motion or something.
it's super slow.
Oh, there it is. Yeah, the film's moving now. What's it doing?
It's Alka-Seltzer going into a bubble of water on the ISS.
Oh, cool. I haven't seen this one.
Watch, he puts it into the bubble.
Yeah.
Look.
Well, that's similar to the a ping pong ball going into a ball, because you see how it just enveloped it straight away.
Yeah, but this is the fact that
it sucked it in. I wonder what's causing that then. I wonder.
But it's an expanding gas not being expelled by the water, though. It's being held in by something.
Yeah.
And look.
Well, it is popping on different sides, so it is expelling.
Yeah, but...
There you go. See at the top there. So.
Yeah. But you see how there's that circle in the middle?
Yeah.
See that hollow?
The gas.
Yeah, but that hollow, that's like how we know that there's a core in the Earth.
Looks like a fish eye.
Pretty cool.
Are you saying the Earth's core is hollow?
No. I did not say that.
Okay, explain. I knew you weren't saying that, but we'll explain. What do you mean?
Well, it's just how it is that a particular molecule moves to the outside of the sphere. But how do we not know if that ball that was in the center was a mix of non-colored gas with the water making it denser, but it goes to the center?
Mm-hmm.
Bit tricky, that, isn't it?
Yeah, but we also know of other ways now that we know the Earth's core is.
We need to get back down here on Earth.
Uh-huh.
Paul and I were just above the clouds. You guys took it into space.
Oh, but
I'm
we
trying
were
to get
onto. Yeah, we're trying to get pressure.
Yeah, they have to get. Well, you got me underwater.
No, we were talking about gas.
Well, water
Yeah.
is a gas
Look,
and a liquid and a solid.
I can't Google and show videos at the same time. Yeah, what was it? See, now I've forgotten what I was going to Google then.
And you were going to Google gas.
No. Yeah, but it was an It's an experiment.
Or that one with the vacuum.
No.
No.
£2.50 would be fucking dead.
I know some people have done it, so I've just got to figure out who's got it.
The Cygnus has just attached.
Better do something, guy. We're getting a crowd.
Are we?
Mm.
The Cygnus CRS-12 cargo craft has rendezvoused with the ISS.
Yeah.
Has it? Have we got a cartoon to prove that?
No.
Come on, spaceman.
You just need to look on the NASA website, NASA page. You'll find it there.
Oh, you're going to send me to NASA?
Oh
yeah.
I've just
Enemy
gone
territory.
into I've just gone into my inbox and we've officially hit Illuminati because Terry Davies is live 33 minutes ago.
33.
Hey.
Now, there's an experiment where people drive a car up a mountain or something with the balloon over a bottle.
Oh, yeah.
Define
seen
the
that,
search.
Terry.
I can't define the search to find who did it.
Is that the one where the balloon deflates
No, inflates.
or inflates, and then deflates when they get down the bottom?
Oh,
Show-
here's
just-
something even more funny. Only Sheeple Can't See has got 33 subscribers.
It's got more than me.
All the ones I get for the ballooning car is the ones where the balloon's hanging and he accelerates forward and brakes. That one.
Or you want the double one?
No, I want the one where you're driving up mountains and the balloon changes.
How did that happen? Oh my God, Deb. Guess what?
You smell?
Nah. I just checked my page. I too had 33 subscribers.
Oh, shield checks on the
What
way.
the hell? Happy days.
Bansal
All right.
Bandit,
Okay.
Illuminati confirmed.
All
Even
right.
though it's a Freemason symbol, but
That's
yeah.
right. I'm gonna close my account now so it stays on 33.
Yeah, Sheeple actually. Sheeple's got the only equation that matters. Dodo times Aristarchus equals 3. Oh shit! Pete Shea will be here in a minute.
I'm taking a screenshot of that of 30 subscribers. I'm taking it now.
What, on mine?
Yeah, as proof in case you deny it later on.
Oh, we've got evidence.
Hold on, I'm going to unsubscribe to myself. Make it 32 again.
And swipe the
Too
screen,
late.
and
Too
I've
late.
got it.
Too late.
Too late.
Too late. Got it.
Oh,
You can't deny it now, and I'm even going to highlight it.
you're going to highlight it?
Yeah. 33 subscribers.
Yeah, put it out on Twitter.
Yeah.
Happy days.
Sword Bandit is Illuminati.
Confirmed. Yep,
Confirmed.
100%.
I'm even going to name the file. Andy Illuminati. Confirmed.
Oh, how funny.
There it is.
Yeah.
On my desktop. Bandy Illuminati confirmed.
Everything accelerating at the same rate.
That's funny.
I can't find a video. All I find is balloons in a car, but not the ones I want.
Ooh.
I don't think many people have done this experiment. That's probably why I'm not finding it.
Oh. Sleeping Warrior is live. Anyone see that thing with Adam Meakin? Who's getting dragged off by the cops?
Why?
Why? I don't know. The cops wanted to know what they were doing. They wanted his ID or something, I think. And he asked the copper for his ID, and then the copper wouldn't show him, and he walked away from the copper, and then they grabbed him and took him away.
There you go. I've tweeted it now.
Oh, you have not. Oh, casual.
Yeah.
Damn you.
I know. I'm so bad.
You naughty boy.
I know. I'm a very naughty boy.
I'm even worse.
Are you? Oh, you even got it up on screen.
Look at that. What's the live chat think of that one?
Oh, what? I can't believe that. That's what I hate about the internet. Everything's recorded.
Well, you got your 1 minute debunk there, have you?
All the globe proof you need under.
Under 1 minute.
You didn't do much research on that one, did you? I squeezed all mine into 12 minutes.
Well, he's beat you in 12th the time.
But I've got more information.
That means that flat Earth has only got 1 minute worth of information.
How do you know it's not a 1 minute video, but it's in fast speed, 14 times the speed? In which case, he's got 14 times more information. Well,
yeah, he could have. Yeah, he could have slowed.
Bandy doesn't know how to do that.
What do I know how to do?
Exactly.
Sorry, I was
edit.
I was twittering Spaceman.
You twittering me again?
I am.
Better check the Twitters.
I thought I'd better follow him.
Twits.
Yeah, always got to check the twits.
Seeing as I'm now an official Twitterer.
I don't think I've got any of your Twitter accounts, have I? I don't know.
I better find Mr. Spaceman then.
I'm
you under
in there.
casual?
I'm in there somewhere.
You under casual or the casual?
No, it's just casual spaceman.
Yeah.
Nice and simple.
Oh, there he is. Oh, look, one tweet in the last hour. Illuminati confirmed. Benzel Bandit. I'm following you.
Yeah, I'll follow you too when I can.
Yeah, but my Twitter handle's Cooley69.
Courtney 69.
Cooley, Couley 69. Because
Sorry,
actually,
say that a bit slower.
Couley 69.
Oh yeah.
You better follow me back, casual. Get me up to 10 followers. I need double digits.
Well, I've got you at your hand. It was Cooley 69. Was it Cooley Divilla or something? Divilla?
David.
No,
Diddler.
it doesn't say that. It says Divilla. It says Cooley
Does it?
Divilla.
Am I?
What?
COLEY 69.
Couley. Yeah.
LEY. Sorry, I've only just woken up, so
How do I find anyone? I don't know how to use this Twitter thing.
You
there
hit
you
the
are.
search button.
What
Yeah.
search button? But can't I just go to somebody that's already and then link through?
Yeah, well, if you tick on your followers or who
Followers.
you're following, and then you can find them.
Followers following. I got
Well,
71.
followers are the
I
people
got
that
71
yeah.
followers.
They're the people that follow you,
Yeah,
And
and now I
then-
go to the following. Or the followers.
and that's who you're following. If you go to followers, that'll be who's following you.
You follow me?
I do.
Okay, so if I go to you, I'll find Casual Spaceman. Well, they and them, I could go to I could go to they and them too.
Or you could have just hit the search button and typed in cash, and he would have probably popped up as the first one.
That's too complicated.
It's a
I'll
bit
go-
too casual for you.
Oh, I just went straight past your name. There's you. Followers.
I better retweet that. There we go. Give it a heart.
Following.
Bam.
Oh, I didn't realise Stupid Monkey was on Twitter. I follow him.
Yeah, he is.
Not alphabetical.
Of course not. Why would it be?
I don't know how to use this stupid thing.
I'll tell you what, when I first started Twitter, actually it took me a while to get the hang of it. I didn't get it at all for a while.
But you've got all these symbol things here. I wonder what that.
How does this Twitter work? Some people get to bloody well Twitter like war and peace, and yet I can only like Twitter about 17 letters. How does that work?
You can do 240 characters.
Oh, I found Casual Spaceman, but I found 2 Casual Spacemans.
Can you?
Shouldn't be.
Yeah, I got 2 here.
Maybe
One's
one.
got @Casual Spaceman, and the other one says @Match Beaching 153.
Oh no, ignore the Matt Beaching one. That's definitely not me. Shh.
Matt.
Talk to me live on air.
You get 240 characters, damn. I only get 130,
Okay.
140 myself.
So where do I
Well, 'cause
follow
you're
that? There you go. I'm following you now, Spaceman.
You need a few more followers, and you need to tweet a lot more, Bandy.
So how
Oh.
many followers you got? 196, 224. Okay.
Yeah, I got like 84.
Is that the problem? I don't tweet enough.
No, I don't use it either.
Well, I was pressured into getting it.
Yeah, I was told to get it.
For some reason, Twitter doesn't recognise the language where I've put Bandy Illuminati confirmed because it says translate tweet underneath it. It doesn't recognise it as English.
Yeah. Because you've written Illuminati and the number 33 appears, so they're just wondering if it's coded.
And I translated it, and funny enough, it says exactly the same thing. And Google has translated it. Oh, well done, Google.
Yeah, English to English. Woo!
Yeah, wow. Yeah. That's fucking amazing. How do they do that?
Thank you, Orb. You just got me up to 10. Happy days.
You will actually get a message from Twitter now.
I did. Yeah, Orb just followed me. Happy days. I'm popular. I'm feeling good about myself now.
How many followers have you got?
Now I've got 10.
Yes, 9 o'clock hero. I do believe FTFE is scraping the bottom of the barrel.
What's he done now?
Oh, he had some stoner on there today.
The same as always. Guys, enough.
What, live? Was he this morning?
Yeah.
You need to
He
go
never
in
goes,
there,
he
Paul.
never goes live in the morning.
Teach him a lesson.
I don't think he went to sleep because just give me a minute.
No, it's probably his sleep patterns probably all shot to pieces. It's the 24 hour, 20 hour stream, I should say.
Yeah, it was 7 hours ago, and it was live again versus Andrew the Flat Earther.
Well, his 20 hour stream went on from, what was it, Saturday morning 4 a.m. our time, and then finished midnight. That's later on that same day.
Yeah.
Well, in my opinion, anytime you debate a flat earther, you're scraping the bottom of the barrel anyway.
Oh.
And basically, he's run out of half decent flat earthers to debate anymore, and so it's just kind of like
What has he had lately? He's had 33 UC, Hip Hop Hippie, Joey Rocha, and now this. And he had Spurs on during his 20-hour live stream, and Vlad. I mean, shit.
I challenged him in his chat, and you refused to take me on.
Didn't they have 33 UC on on the joint one they do between Team Skeptic? What do you call it? Science of Satire. Wasn't he on that one? Wasn't he?
Yeah.
Yeah. I don't think he was on FTFE's actual stream. I don't think.
Bandy.
Oh, thank you, Terry.
Bandy, you don't follow me.
No, I'm about to, my friend. I just got a notification. Now I can follow you.
Well, I mean, what's the point in debating 33 UC? Because every question you answer is just going to be 33, isn't it? You know.
Yes, I do.
Everything happened is 33.
Yeah, or some form of it's 9/11 this or something like that.
Yeah. Then he works out something that is related to 33. If it doesn't add up to 33, he adds something to make it 33.
Yeah.
Oh, for fuck's sake.
I'm not having any luck finding these videos.
I've got a stream later on.
Yeah, I got one here that I was.
Yeah, Boeing Starliner is doing a pad abort test. I thought it was I thought it was the Dragon doing the test this week, but it's not. It's the Boeing Starliner.
Yeah, I've got one here for you that I'm going to watch in a minute called Amazing Hubble Discoveries.
Who did that one then?
Yeah, I don't know. I've never heard of him before.
Yeah.
Who's that then?
I think his name was Matt.
No, that's definitely not me. My name's not Matt. It's just casual.
Oh, it's the causal inconvenient space.
Yeah.
Yeah, I've got that on me tabs ready to play. But I want this videos that I know I've seen. I don't know who did it. I reckon they're cool.
If you do play it, you can play the video with music because the music is from YouTube, so it's all good.
Oh, okay. I don't think I'm going to... I'll have to wait till Peter gets in here. He might be able to find him. I can't find him.
God,
and I don't talk in it, which is good.
It's already 2:30.
I hate the sound of my own voice. I really do.
Oh. Isn't it the worst when you hear yourself supposed to back?
Yeah.
How long does it go for? 10 minutes. I'll just turn the volume down a bit.
Yeah.
Keep me cuppa up.
Choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Because they are hard.
One small step for man.
Step for man, one giant leap for mankind.
Look at that, Bandy.
You got a lot of CGI.
Okay, it was discovered in 1677. So how did they do the CGI back then when it was first observed?
That wasn't taken in 1677.
Bandy, don't twist my words. How did they see it in 1677 if it's a CGI image?
Exactly. Did they have telescopes back then? How did they see it?
Yes, they had telescopes back
Must
then.
have been pretty good.
There was a bright star in the sky anyway. They
Yeah.
could see it with the naked eye. It's a bright star for a while anyway.
Hmm.
What's that star you claim that's going to become Polaris? Sam?
Vega star.
Vega star, that's right.
Yeah.
Little pick. What's known about some of these pictures, as into what enhancements they use or not, or is it just in the photography part of it?
I'm not sure, to be honest with you.
They use
It would be enhanced definitely once they've got it. for
yeah
sure.
they use is it spectroscopy color charts?
Yeah, something like that. Yeah.
They use they gather the radio frequencies from the location to check the range of colors. All sorts of things they do to do that. Plus, if it's taken by Hubble, it's just how the photons fall on the lens, and then interpreted by the computer. Look, the Hubble bubble.
1990. Wow.
Yeah.
Yeah, and it's still
Doesn't seem
going.
like that. It really doesn't seem like that long ago. It really doesn't.
Yeah, I was like 14.
Yeah, my kids were born around that time.
Yeah, next year's 30 years of Hubble.
Yeah, and I remember all on the news as well when they first switched it on and it was all wrong. It was like, oh no.
Yeah.
Yeah, and then they had to send up an astronaut to kick it in the guts.
Yeah.
Well, that's basically what they said it was. It just needed a kick.
Yeah. I know when they fixed it as well, then for there was a heart attack for a while because they couldn't close the main doors. The doors wouldn't shut properly.
Yeah, he couldn't get it to go up over the locking mechanism.
Yeah. Struggled for a while. They got it eventually.
Yeah, he got the top lock, but he couldn't get the bottom one.
No, that's right.
It's like when you got doing your doors in summer and they don't shut properly.
Yeah, that's right. Yeah. Yeah. So the red spot's getting smaller and smaller. wonder how long it will take before it disappears altogether.
Or is it cycling? It could get smaller and then get bigger again.
Yeah. Well, like I was saying on there as well, it was getting taller. It was getting taller and taller, but narrower and narrower. Saturn's my second favourite planet after Mars. Saturn's amazing.
I like Saturn. Rings.
I actually like Venus.
And that that weird hexagon pattern it creates on the top.
Yeah, there it is. Yeah.
Is it Neptune or Uranus has got a similar looking one on its pole?
I didn't know that actually.
Yeah.
What, has it got a hexagonal shape as well?
It's not as defined as Saturn's, but it's got a similar one at its pole.
Okay, I didn't know that.
And actually, they're also trying to work out if the storm on Uranus is faster than the one on Jupiter.
All right. It's not as big though, is it?
No.
Well, it's not. The planets are completely different sizes anyway. Stupid statement.
Yeah, I'll let you say that.
Exoplanets. Oh, I love hearing about exoplanets. I think most of us have probably heard about this bit anyway.
Yeah, no. I understand that why they call them exoplanets, but they're still just planets.
As well, one thing as well, I didn't actually realise until recently, but an exoplanet doesn't necessarily have to be in the habitable zone either.
No, it's just one that's out of our system.
Yeah.
That's all it is.
Yeah, up until some months ago, I just thought the whole point of an exoplanet was it's supposed to be in the habitable zone, but that's not the case.
No.
Do we say water as in water inverted commas, or do we just know it's water?
Say that again.
Because water could be liquid, other liquid gases of some sort. It'd just be liquefied. Like on
no, when they refer to water, they literally refer to H2O.
Okay.
They don't call anything else water.
Yeah.
Yeah. It's like how is it? Titan has methane rivers.
Yeah, that's what I was meaning.
Yeah. I'll look that up.
Did you say methane rivers?
Yeah, at a particular temperature, methane is a liquid.
James Webb. Can't wait for James Webb.
Yeah, it is on Titan.
Oh, where did we go?
Not too much longer to go for James Webb before it's launched. Not too much longer.
Yeah, they said 2021, didn't they?
Yeah, March.
Yeah.
Well, that one's coming close.
Yeah, Comet Borisov.
Straight past us. Yeah, but are they in an elliptical orbit around it in our solar system, or are they just past?
It came from interstellar space.
Wow.
So no, it didn't come from our solar system. Classified as an intergalactic visitor.
Yeah.
They're not like in the movies where they throw meteors at Earth.
They throw meteors at Earth.
Oh, I saw a movie like that one.
Gennady Borisov, 2019.
Forever. Yeah, won't never see it again.
So it must be in a trajectory that's going to head back out into interstellar space. Then I guess.
Yeah. Yeah, well, it would. It's velocity.
Yeah. 110,000 miles per hour.
Terry, if you look back in Fair Suck, I've put a link to an image of Titan's methane lakes. Look at that, Bandy. That's methane. That deep blue, that's liquid methane.
How do we know this?
Because I said so.
Yes, but how do we?
Okay, the Cassini-Huygens craft that went around Saturn took pictures of this and also used, I can't remember what the instrument was that it used, but it gathered information about the, well, actually, it would have been from particles of outgassing, I believe, that worked out the composition of what was being ejected from the planet. It worked out the composition of the atmosphere, and if the atmosphere contains particular molecules, that would be why it's methane and not H2O. I believe that's how they figured it out.
You can work out what something's composed of by shining certain light on it and seeing what gets reflected and analysing the spectrum of the reflected light, because the methane will absorb certain spectral lines from.
Oh, would that be
spectrum.
spectral analysis?
That would be spectral analysis. Yeah.
I'm cheating. I just read 9 O'Clock Heroes comment.
Yeah. You don't have to literally detect molecules or particles of the actual gas itself to know what it is.
I'd still like a sample of it just to confirm it.
Okay. Well, next time someone's flying over there, we'll get them to get a sample.
Yeah. Look, I'm happy to call it methane, but it could be something else. I won't change it to the ether band or anything.
Oh, it actually measured its isotopes. Wow.
Yep.
That's amazing. Hang on, I've got to go. Oh, fucking hell, how long's this article? I hate it when they write about
that's literally how we know what the sun's made of and what other stars are made of too, what their composition is.
Spectroscopy.
So this spectroscopy.
Spectral analysis. Spectral analysis is far easier to say that.
If I get one of these machines, Paul.
Yeah.
Yeah, well, you know I'm not, but if I was getting one of these machines, right, and I point it at a cardboard box, will that tell me it's a cardboard box? Or if I point it at a chair, will it tell me it's a chair?
No, it won't tell you it's a chair. A chair isn't an element on the periodic table.
Well,
can you imagine Bandy? Imagine Bandy's periodic table. So hydrogen, helium, oxygen, carbon, nitrogen.
No, I was just going to say carbon if you burn it.
Yeah. Chair, table, couch.
Okay.
Barbecue.
So it only works with elements, does it?
Yeah. Yeah.
Okay then.
And not the element in your toaster either.
Okay. Well, I'm just clarifying.
It's a classic, that one.
Oh, it's funny.
Well, here you go. Titan's atmosphere is mostly nitrogen, about 95%, and methane, about 5%, with small amounts of other carbon-rich compounds.
Okay. So if I point this spectrometer at a piece of iron, it'll tell me it's iron, yeah?
It's not a matter of pointing a spectrometer at an object like it. Basically what you're doing is you're analysing the light that's given off of an object. Okay.
That's reflecting off it, yeah?
Well, there are a couple of ways of doing it. You can either shine your own source of light on it and see what's reflected, and by analysing what's missing, you can tell what the substance the object's made from. Or you can analyse the light that's coming from the object itself, because different elements emit different kinds of light.
Yeah.
We can literally tell what's in the sun's atmosphere by looking at what parts of the spectrum are missing, because those gases absorb certain lines in the spectra as the light comes towards us.
I'd be far happier with a test tube of the sun's atmosphere.
Yeah.
Just to confirm it. That's all. Just to confirm. I'm not denying it. I would just like to confirm it.
So, Bandy,
Yes.
you would like a flask of
The sun's atmosphere.
atom smashing.
You want a pint of atmosphere of the sun, do you?
Yeah. So we can test it, like a test tube of it. Yeah.
of atoms smashing together.
Yeah. Well, then we could confirm it. It just wouldn't be a theory then, would it? We could make
Andy?
it a law.
Bandy, do you realise if you had a flask of the sun, you wouldn't be here?
Well, that's not the point, whether I'd be here. It'd still be nice just to have just like a little bit of it.
But you wouldn't be able to have it.
Well,
Plasma.
they probably wouldn't give it to me if they got one. I'm giving you the hot tip right there.
You can't scoop up a cup of sun.
Why not?
Plasma.
I just want
'Cause it's
the
plasma.
sun's atmosphere. I don't want the sun itself. That's a bit extreme, expecting someone to land on the sun and drill a hole and get some core samples and stuff. But that would be handy if they would do that.
Next time you've got a bonfire going, Bandy, walk up to it and grab it and have a cup in your hand and grab some fire.
Actually,
Yeah,
here's another one.
And go and show your mates.
Yeah, get me a cup of fire.
Get you a cup of fire.
Yeah, cup
Yep.
of fire. Yeah. Next time you've got a bonfire fire going, just grab a cup full of fire.
Okay.
Cup of flame, thanks.
Is fire
just
hot?
you
or
only-
is it
only
just
want-
less
you-
hot?
We only want the flame. We don't want anything else. Just the flame.
Yeah, just the flame itself. Yeah,
Oh,
Yeah.
I don't know.
a nice
talking about-
yellowy, orangey part would be perfect.
Yeah.
So I want the cold fire.
Yeah, we don't want blue flame. We want orange flame.
Exactly.
Yeah.
Exactly.
Yeah, but if you, well, actually, here's the other one, Bandy.
Yes.
Can you give me a cup of you?
I could, but it'd be painful.
But how would you do it?
I'd get a cup. I'd sharpen the edges.
No,
No.
What do you mean? No.
no. Okay,
You
just
just
a
asked
plain
me
old.
how I would do it.
Hang on, Bandy. I'm going to change the goalposts here. Hang on.
Okay.
All right. A coffee cup
Yes.
that doesn't have any sharp edges.
Mm-hmm.
Get me a cup of you.
Okay then. Well then, now make it a bit easier for me because I don't have to sharpen the edges. I just get a knife.
No,
Slice and
you
dice.
have to use the cup.
Oh, I can only use the cup.
Yep.
Okay then. Can it be any part of me?
Well, it has to encompass every single molecule of your body.
Okay, then no drama. I'll just fill that cup full of piss.
But that's not every molecule that's in your body.
Yeah.
How
Of
about
course it is.
How about we get Bandy and put him inside Paul's blender and then put him in a cup?
Yeah, we'll make Bandy mush.
My brain goes to much talking to you guys.
No, but this is the same as trying to get a cup of sunshine. You can't just scoop a cup out of you. It's
but
like
see-
you can't do it to the sun.
But see, I can get a cup of the Earth's atmosphere.
Ah, but no, the sun isn't like the Earth, mate,
Why not?
because it's plasma.
Yes. What's the point?
The Earth isn't plasma.
No, when did I say the Earth was plasma?
But you said you could get a cup of Earth.
Yes.
And I said you can't get a cup of the sun. But you said I can get a cup of Earth. So therefore you're
Exactly.
making the analogy that if you can get a cup of Earth, you can get a cup of the sun.
Yeah, well, you just get a cup that's got a high temperature resistance to it.
What substance would that be, Ben?
You get a flask.
Asbestos. Say asbestos.
Get a
man.
thermos.
Thermos.
You need a thermos. Would a hot water bottle do it?
Asbestos.
It can take heat.
You'd need a magnetic flask, Bandy.
Flask. Actually, I didn't know magnetism could bend light.
So can gravity.
Don't bring in some fictional thing into the conversation.
You'd need a magnetic bottle to hold a cup of the sun, Bandy.
A magnetic bottle.
Yep.
Okay,
Yeah,
then.
but that magnetic bottle would have to be able to hold the temperatures of about 5,500 degrees.
Oh, that's easy.
Well, it depends where you take the cup of the sun from. 5,500 degrees is only the photosphere.
Yeah,
How
I
would you
know.
How would you get close enough to the sun to actually get the cup that's thermal
I told
resistant?
you, wear an asbestos suit.
Do you think that
Okay.
would be enough, Bandy?
I don't think so.
Oh, I don't know.
Hang on, we'll have to look up heat resistance of asbestos.
It's got whiskers on it, that idea.
Oh, you could
Change
use that
part.
gel. You could use that new gel, Bandy.
Aerogel.
Aerogel.
Exactly.
Aerogel, yeah.
Exactly.
You could make your spaceship out of aerogel to get you close enough.
Thermal resistance.
Then put
of
your
silica
asbestos glove on
aerogel.
and then reach out and grab a cup full of the sun.
Stop picking on me, Leah.
So grab a cup full of the cup being a thermos flask that is also magnetic,
Yeah.
that holds the plasma. But what would happen then when you open the flask when you get back to Earth with it to analyze it?
Oh, yeah, that's an interesting question because now it'll be an open container. So it'll be an open system, not a closed system, for starters.
Wouldn't it be an open system inside a closed system?
You could open it up in a vacuum.
But if we're in a closed system, how would you get to the sun to begin with?
Well, exactly. That's the problem. I see your dilemma there.
It's your dilemma, not ours.
What's not my dilemma? How can it be my dilemma?
You're the one
I'm not
going.
one-
You're the one going.
Get me a ticket. I'm there. I'm going. Happy days. You keep on offering to get me a ticket to the ISS, guys. I'm still waiting for it.
When's their next launch?
I don't think Russia was going pretty soon.
Well, you get a cheap ticket with Russia.
SpaceX is going to be doing it pretty soon as well. Might be easier if you're going to Russia.
Hey, Bandy, you might have a bit of trouble getting a cupful of the sun back through customs, though.
Yeah, that'd be the one issue. Yeah.
So you know what most people do when they want to hide something and get it through customs. What do they do?
Yeah, you get a couple of condoms.
Excuse me, sir. What's inside this container? Sun.
You shove it down your pants in your undies, right? And
Yeah.
and if the magnetic bottle broken, you'd really have the sun shining on your ass.
Oh yeah. Put a smile on my face.
Yeah, all right. Slight problem with your aerogel idea. It starts to fall apart above 200 degrees C.
Oh, right, okay.
Oh, really?
Well, silica aerogels are used above 200 degrees C, but you get about 150 above that, and it will start to fall apart.
Oh, I didn't know that. There you go.
Yeah, well,
What
it's
about-
used instead of silicon for heat resistance now.
Can't he get a hold of some of that unobtainium?
No, you can't.
Unobtainium.
That's the whole point of unobtainium. You can't obtain it.
Exactly.
Jesus. If you could get it, it wouldn't be called unobtainium.
Mandy wasn't to know that.
That's a paradox right there.
I was going to tell him he could get it on Amazon.
But it's not.
Get it shipped to your door.
It's unobtainable everywhere else apart from Amazon.
Yeah.
Amazon can get you anything.
As soon as you get a sample of it, you've got to change its name to obtained. Obtainium.
Yeah,
But
fictional
then would you
engineering.
sue the company to say, look, this is supposed to be unobtainable, I can sue you.
Oh, for fuck's sake, I'm dying.
I told you to lay down.
Actually, unobtainium is actually a Chinese cryptocurrency.
Oh, that brought the conversation straight now.
Yeah.
Where were we? We were still talking about pressure gradients, weren't we, Bandy?
Were we? We were talking about getting a cup of the sun.
Oh, okay. Oh, now we've gone to get a cup of sun.
We've gone from water to the sun.
Do we want any sugar with our cup of sun or milk?
Well, actually, I'd more be thinking about the radiation that he might be getting from having that cup of sun stuck down his undies.
That's all right.
But it's also radiation proof. It's lead lined as well as magnetic and thermal.
Oh, okay. So the lead poisoning that he'll get from stuffing it down his jocks.
I'll just make sure I'm wearing my zinc cream to give me plenty of protection.
Zinc cream.
As long as he doesn't grab a bit with a bit of lens flare, because then he might be getting a bulge.
Lens flare.
Try and get a cup of lens flare of solar flare.
Yeah.
That would probably be better because that's actually stretching out from the sun, so you could probably better off getting a cup of that than getting a cup of sun.
Get it at the right time, yeah.
Yeah.
Mm. So
You got
how hot
a
do
mission.
you think the sun is then?
What was that?
Pretty warm. You could toast a piece of bread off it.
What was the question, Bandy?
No, because you're going to tell me to Google it myself, so I better do it.
How hot is the sun, you say? About 5,500 degrees at the surface.
How hot? 55. 5.778 Ks.
That'd be Kelvin.
5,800 Kelvin.
Yeah, that's my middle name. You're not
That's
allowed to use that name.
Temperature of the surface of the sun, 5,600 degrees Celsius.
So they're saying that the sun...
In the centre, it's 15 million degrees Celsius.
So they say, but they haven't dug down that far. But...
They used a thermometer, Bandy.
So what they're saying is basically the temperature of the surface of the sun is the same, or thereabouts, pretty close to the core of the Earth.
Close.
Yes. Interesting. Now, when do they measure the temperature of the core? How do they do that?
They stuck a thermometer down there.
What orifice do they stick the thermometer in to test it?
Through the Marianas Trench.
I still can't get my head around the fact that the 6,000 degrees doesn't thermally transfer to the surface of the Earth, even though Paul has explained it to me. No, it doesn't the way you would expect it to.
Then we're not ganging up on Bandy. Bandy, are we ganging up on you?
No, there's not enough of you to gang up on me yet.
Okay.
Yeah, he hasn't
Well,
given
you
us a reason
can
yet.
bring they and them in here to help you.
Yeah, look, now Dean's bloody putting his 5 cents worth in too.
Oh, that'd be right.
How far can you dig, Dean? 8 miles? That's it. That's it. Dig a little bit deeper.
And Dean's going to bring facts into it now.
Take your MEMS accelerator thermometer and get me a reading.
I don't share the
You-
link anymore,
you-
they and them. If you want it, I can give it to
Even
you.
8 miles down, it's pretty hot.
It is warm the deeper you go. I will grant you that.
DM in Discord if you just want a link.
Don't you put it in the secret place.
Yeah, I still put it in the secret place.
Yeah.
The
Not
spe- the
everyone has
special,
access to the secret place.
the special place.
Oh, don't they?
Special place.
Ah,
It's only invitation only.
invite only.
You have to be a special person.
They already asked you, Terry, he reckons.
Did he?
You bloody
I
Kiwi.
wonder. Oh, that Irish twat.
Yes. But then he's going to come on with bloody a circular argument in a minute.
Would he?
I reckon he might.
No, he wouldn't
know-
do that.
Do you know how he knows how to make a circular argument, Bandy?
Who knows how to make a circular argument?
They and them.
I know. He's pretty
Do you
good
know
at it too.
Do you know how he knows?
Should I be getting ready for an insult?
Well, no, you should know how because he's they and them. You know the infamous they that everyone talks about?
He's also them as well.
I always
Yeah.
talk about them.
Yeah, but is there more them or is there more they?
Well, it depends.
Depends on the bacon division.
Depends how much bacon he's eaten in the morning, I think.
No. The bacon division is the secret police of the they and them corporation.
Oh,
Hey,
it's a
babe.
corporation.
How you going, buddy? Mr. Bacon Guard.
The non sequitur said, "Okay, I'm here now."
Morning, folks.
Morning, they and them.
Good evening.
Howdy.
Oh, it's changed it back to Bacon God again.
Yeah, he's of course
Yeah,
he's the
yeah.
bacon god. All hail the bacon god.
I'm confused.
You
I'm
gotta
confused.
check
Again.
Why was he before?
It was they and them just a moment ago. Now it's the Bacon God. I'm
Oh.
confused.
You got to change
Yeah,
it.
you see, this is why you think you live on a sphere, spinning through space, because the simple things confuse you, and you're trying to tell me and Bandy what the sun's made of.
Mm-hmm.
Well, I was going to say fused pixie farts, but you know, instead we got plasma.
So what is the sun made of, God? It can't be bacon.
How would I know? Can we get there?
Yeah.
No.
Actually, we
Well, it
can
doesn't
because we've
exist.
actually got a probe out there right now.
We've got a probe. We've got a probe next to the sun at 6,000 degrees Celsius. Do we?
Yeah.
No.
Yeah,
Ah.
so it's closest that any man-made object has been before ever. It's got this
Yeah,
great big.
sorry,
huge
and
shield around it.
even if your space exists, how far away is it still?
Okay. We are close. They are far away.
We're not talking about perspective, demonic. You can't even have this conversation.
They and them. You saw the conversation I had with Aaron earlier today.
Yeah, you got angry.
No. I got angry at I kept going for goal and I kept missing because they kept moving.
No, goalposts never move.
No, not with
Look-
Aaron. Goalposts are simple. He's not a flat earther, and he still gets people to bite. He's just a very good fisherman.
You just don't know how to kick them. That's your problem.
Oh no, I kicked 3 straight.
Well, you can't. If he's moving the goalpost, you can't be a very good shot.
Oh, I kicked 3 straight. It's just the goalposts weren't where I was kicking.
Oh, whose fault is that?
Well, it's not mine because I was kicking where the goals were.
No. You should have been anticipating. That's what a good kicker does.
Yeah, the same way you have to anticipate this moving earth that you say we're on.
Mm.
The interesting thing is that sometimes the Flurfs shift the goalposts so much that they end up kicking their own goal.
It's called an own goal.
Yeah.
Hey,
And that's
Stingray.
called proving the globe.
How are you doing?
Oh, Dean, how we going, buddy?
Yeah, not too
Oh,
bad.
they're that worried now. They're bringing on more people, Bandy, to pick on the two of us.
I know.
No, Dean's got nothing to do with flat Earth anymore. He said he's had enough.
Anyway, do you know that probe we were talking about that's going to the sun? It's only going to the outer corona of the sun.
So how
Parker probe.
How hot is it there?
Well, it's just going to park, right, and get a ticket.
Wait a minute, Bando, you just asked how hot it was there, yeah? How do you think heat transfers?
That's not the point. I just asked.
It is. It absolutely is the point. If you're insinuating that packed there, it would be too hot for it, my simple question to you is, how do you think heat transfers, and what is heat?
Well, it's something that's not cold.
He's right. He's right there. He's right.
Now
There is no
you've
such
told me.
thing as cold.
Now
There
you-
is no
now
such
you've
thing
told
as
me.
cold. It's an absence of heat.
That's right.
Right, now you've told me what it isn't. Now tell me what it is.
And anyway,
How's
you can't answer my question with a question. That's not how it works.
I'm just going to make sure. I'm just going to
Right.
make sure that the answer that I give you will understand. And to understand it, you first have to tell me what heat is.
No, I don't. Because if I don't understand the answer, then I'll ask for clarification.
Okay. There is not enough matter to transfer heat when there is no matter in between you and the object that is radiating heat.
But there is
The
matter up
only
there.
The only thing you think there's matter in space, there is, but it's like probably 0.0000001% density, which means 20 million degrees, you would still be able to wave your hand around in because
Yeah.
there are not enough particles to transfer it to your skin.
There we go. You guys are telling me we can't get a test tube of the sun and bring it back to the Earth. What the hell?
Bandy, hang on. Hang on.
Yes. I
Now
love
you're
these
telling-
conversations.
Now you're telling me it's not hot. What the hell? Because there's no matter there. Like, you made me take up a bloody.
No.
Tesla.
The sun has lots of matter, and don't get me wrong. If you get a coronal ejection, which is matter bursting out of it, and that matter hits you, you are fried. Now, the sun also gives off multiple layers of radiation, which you'd fry as well from it. But the actual heat, which is vibrations of atoms moving around, there's nothing to vibrate, just like there is no sound. That's why the ISS can sit in the thermosphere. There isn't enough hot air up there to transfer it to the ISS. And if you just simply build it out of aluminium that's shiny, the radiating heat just gets reflected away.
Did you just say there's no sound in space?
Yeah, no one can hear you scream.
So you're trying to tell me if I'm an astronaut in space, right, and I'm doing my little spacewalk, and I've got my mate on the other side of the ISS, and he's doing a little spacewalk. If I shout,
I've missed talking to you, Bandy. That is awesome. However, inside the little dome, there is oxygen, and inside there is a microphone. The oxygen vibrates, and it is what we call sound to the microphone. If he tried talking outside his little bubble that he's in, yes.
no. I'm saying if he takes off his helmet now, and he's takes off his helmet, and he shouts out, and he goes, "Hey, pass me the cordless screwdriver."
It'd make no sound.
Two things.
There's nothing in your throat.
One, no sound. Two, he would die within a few seconds.
Yeah, I didn't say to take his helmet off for more than a few seconds.
Bandy,
I said like 1 second, just quickly.
Hold your breath.
Go, hey,
You hold your breath, Bandy, wouldn't you?
Right. So therefore, you're saying he can only talk to himself inside his spacesuit.
Correct.
No. The radio signal will be transferred to the other bloke.
Yeah, unless you use a radio system then you have the
Just what they
capability to
use.
talk. Yeah.
Yeah, the
Right.
amazing thing about radio waves is they do not require matter to travel across, just like light.
Okay. Now
They are electromagnetic.
So this theory that you guys are talking about that you can't
Demonstrated.
do in space, right?
100 times proved every day. But yes, go on.
Really?
Hmm.
Where?
Yeah.
So do you know how condensed? There are
okay.
there are speakers that use vacuums inside them. Why do you think that is?
And we're talking about space here. We're not talking about vacuum.
No, we're talking about sound transmitting through matter and the fact that radio waves don't require it. And I'm just saying we use vacuums and the lack of matter to control things like sound and frequencies through speakers, and everybody has them.
There we go. But let's get back to space.
Okay, so let me get the X-ray so we can properly look inside your head. Okay, now go.
He's got a clear dome. You can see through it.
Exactly.
Bandy, I've got a little story to tell you
Yeah, it
about
looks like a cervical cap.
There's a particular camera on the ISS that watches the astronauts when they do spacewalks to repair stuff on the outside. Do you know that camera actually has a microphone on it?
Well, you'd expect it would.
And guess what?
Why?
Wouldn't you?
It
No?
hears nothing.
Well, that's because no one's talking. If they were talking,
They need to take the helmets off and shout really loud, and it'd all be recorded. It'd just be there. Space turns people's voices. They can't normally sing, but if you sing in space, you sound awesome. It's amazing.
If they fart first and then sing loud enough.
Are you telling me nobody can hear my guitar in space? Damn it.
Correct.
Well, yes, that's what you guys are saying.
Oh, wait a minute.
Only 'cause you
just
can't-
come up with a really interesting question here. Someone mentioned fart. If you fart and that fart crosses space into someone else, does it also carry the sound? That'd be interesting.
Only if it was electromagnetic fart.
Inside a spacesuit.
But yes, the camera that sits on the outside to check the astronauts coming out of the tube to make sure they don't get caught or let go actually has a camera on it with a microphone.
Yes.
But it doesn't hear anything as they come out of the door.
Yeah, because they're not talking. Do
No,
they ring the
it's-
doorbell?
But it doesn't
Before-
hear the door
when they're opening up the
open.
door?
It doesn't hear the door open.
Well, that's because
It
they're
doesn't-
using WD-40 on the hinges or something, probably, and they're not squeaking.
I've got. There's
guys.
a good example of this when they're doing their spacewalks for repairs that actually take a lot of physical force, which sometimes they do. Sometimes they're braying on the actual outside of the ISS, properly hitting it, and I've seen cuts to the inside where you can hear the vibrations traveling through and it's producing sound, but on the outside there's no sound. On that camera on the outside and on their helmet cams, there is no sound.
Okay, Dean. Right.
Also, their helmet cams are tested whilst they're inside the ISS, and they actually carry sound.
Hmm.
Have you got a demonstration, Dean?
If you set up all the apparatus, including a massive vacuum, and get the equipment, yeah, we'll easily be able to demonstrate.
Yeah,
it,
no,
but
I was about
unfortunately,
to I don't have actually.
Yeah, I don't have 20 million quid to spare at the moment.
Yeah,
Unfortunately.
if you
Well, I tell you
Bandy.
what, while Stingray's here and Jared's here, can we go back to see what Bandy was talking about? He wants to get a cup of the sun. Can we go back now that Jared's here? Perhaps Jared can offer his opinion about trying to get a cup of sample of the sun.
Bandy, have you ever seen the end of a plasma torch?
Yeah, of course. Yeah.
Do you think that you could fit what is at the end of the plasma torch inside a cup?
Of course you can.
How?
Really? You can contain highly energetic plasma inside a cup.
Oh no, you just said, "Oh, can I fit it inside the cup?" You didn't say if I could contain it.
What's the fucking difference?
A big
A cup is just
Hang
no.
on.
A cup is a type of container.
Yeah,
and here's the thing. If you take that tip of the welding torch and point it towards a cup of any substance,
Yep.
it ain't gonna last.
Yeah, but heat doesn't transfer because there's no matter up there.
What is heat, Bandy? Heat isn't an actual thing. Heat isn't a fluid. It isn't a substance. There's no such thing as a substance called heat.
Well, let me correct him. Let me correct him on something. Let me correct him on something there.
Jared, I just need to give you a parameter. Okay, a cup in regular units is 250 milliliters.
Oh, I'm just talking about the vessel, not a measurement.
Yeah, but this is how much. There has to be 250 milliliters of said product.
Yep.
Okay. So if you were to try to get that and have it be the highly energetic plasma, here's the thing: it's not heat.
Plasma.
That does. Yes, I tried. It is more energetic than the liquid hot magma. So that's why we have to say it the right way.
Plasma is just the burning bacon grease of bacon earth.
So, anyways, this idea of heat being the issue when it comes to plasma, like on the end of a torch, at the end of a welder, is wrong. It's not heat. It is energy. The more energetic a system, the harder it is to contain. The harder it is to manage that energy. So if you try to take highly energetic plasma and keep it at the level that you're getting of the energetic plasma that is the sun, nothing will survive it.
Are you saying it's because it's too
Except
hot?
a magnetic bottle.
No,
it's too hot.
no. It has nothing to do with heat. It has everything to do with the energy level.
That's right. Plasma being charged particles, the only thing that will contain that kind of temperature is a magnetic confinement. Good luck with that, because you need an extremely strong magnetic field, which would require extremely strong electromagnets, which would require a shitload of electric current.
Actually, a really good example of that was Doc Ock in Spider-Man 2. He couldn't contain the sun.
Just get a few solar panels up there to create the power you need. That'd be easy.
What?
Paul just said you need a shitload of energy for this magnet. Just get a few solar panels up there.
Still not enough.
Well, okay, then get a lot of solar panels.
Still not enough.
Hang on. In order to have it be in such a way that the solar panels would not break down from their own energy pickup of the sun, have you ever heard of a Dyson sphere?
Funny you should mention that.
That's what we would need, and we don't have the technology.
Well,
I thought they vacuumed the
No,
floors.
we don't.
Besides, Bandy, why do you want to go to the sun and get a cupful of sun for anyway, when the sun's quite busily throwing stuff at us all the time anyway?
Well,
we can just wait here and catch it as it comes towards us.
Yeah, just get some cosmic rays.
We can fill our buckets up with sun.
Yeah.
Go test it.
But how are you going to get a 250 milliliter measurement of sunshine?
Well, here's the point, because you say that light has matter. Yes.
No.
And
I don't think anybody said.
Don't confuse sunshine with sun.
Yeah, the sun is a big ball of plasma, which has matter. Light is an electromagnetic wave.
But it doesn't have
energy.
Photons in it, which is matter.
Photons have no mass.
Yeah, so it excites electrons.
So light has no mass. Be very careful how you answer this question.
Yes, I know you.
Yes, you know, don't you?
Andy, let me say something. It has no rest mass.
There you go. That's good.
But it has.
Anyway, Bandit. A better question is, let's say theoretically we get you a cup of sun. What are you going to do with it? Why are you wanting it? What are you going to measure? What are you testing for?
Oh, we want to see what it's made up of, because you guys are saying it's made up of plasma. Because we look through a spectrometer.
So my question is, do you believe in hyperspectral cameras?
Hang on, I have to correct something there.
What?
The premise that the Earth is composed of plasma is not from the spectral analysis. The spectral analysis tells us what elements are present in the sun, not the energy state of the sun. Plasma is an energy state.
And it's those molecules that are tested that we
Okay,
found
then.
out that are colliding with each other that create the plasma.
Okay, then. So what's the sun made up of?
Hydrogen, helium.
There we go. There we go. So it's made up of something. That's what we've got to test. Instead of just...
And that's where spectral analysis comes in. Because
Yes.
every
Yes, and
element
you're
has a
assuming that
transmission
it's
line.
the same inside the medium of space.
Yes. But, right, that is just one test. We want to confirm this test, right? We can't just go with one. We want to confirm it.
Bandy,
We want
did
to
I
try and
just,
debunk it.
Bandy, did I just not tell you that there is a probe next to the sun?
Yes, and I said put a test tube on the end of the probe and bring some sun back.
And we keep telling you that test tube will not survive.
Well, that's what you keep on saying. No, that's not my fault. You've got to invent a test tube now.
Bandy, all right. You just cannot get a physical sample of sun.
Now, does light have matter?
What?
Does light have matter? Light.
Yes, light.
No.
Okay,
No.
which light?
Any light.
No.
It
If
doesn't
you're on
have
about
matter.
an EM, no. If you're on about an EM energy, then no.
Well, I'm talking about light that we see.
Yes. Light is a part of the EM spectrum. Light is carried by what we call photons. Photons have no rest mass.
Okay.
So
then.
the answer to your question is, does light have mass? The short answer is no.
Well, what's the long answer? Is it the long answer yes?
The long answer is no, 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 no.
No,
Okay, then.
no. The long answer is light is a photon. Photons do not have a rest mass.
Okay, then. If it doesn't have a rest mass, how can it be affected by gravity?
Because it has relativistic mass.
So ask yourself this, Bandit. Ask yourself this: does a magnetic force have mass? Yet it's able to exert a force on something, or there is an interaction there of energy, correct?
Yes.
So you can measure a force from an electromagnetic field or the electromagnetic force. And it's the same with light, which is why your argument is light has a force, which it does.
and this probe of yours is still according to your scientists, is still 15 million miles away from the surface of the sun.
There we go.
You see, in relativity, Bandy, it's not just mass that distorts space-time, it's energy as well. So light being energy, carrying energy, will also distort space-time as well.
That I did not know. That sounded cool.
Mm-hmm.
Yeah,
Not much.
Oh yeah, no, minuscule. I could imagine that, but I didn't know that it would, because obviously. Oh no, obviously, if it's carrying, if it does exhibit mass.
Actually,
then,
there is a test that was done to see how it does that. It's called the gold leaf experiment.
Oh wow.
No.
That shows that at different wavelengths what it will do to a set of gold leaves in a particular container.
Yeah.
Does dark have mass?
We don't know.
You mean how?
Well, which dark are you talking about? Dark matter or a shadow?
Well, dark, as opposed to light.
We don't know.
So does dark have rest matter?
Dark
No.
is just an absence of light.
No, dark is about the same matter as pink or yellow.
So is dark bent by gravity or speedy space-time as well?
Bandy, I just asked you, which dark are you talking about? Shadows?
No, dark.
Bandy.
Shadows isn't a dark. Shadows are a shadow. Shadows caused by light.
Shadows caused by light?
Of course. How else do you have shadows if you don't have
How is a shadow caused by light?
Do you
when
get
a shadow
shadows
is an
in the
absence
dark?
of light?
Do you get shadows in the dark?
Yes.
Really? Really? You get shadows in the dark?
Yeah,
Bandit, dark is a relative description of a spectrum of grayscale, let's say. So depending on how dark, yes, you can still have shadows in dark.
Oh,
And-
I'm talking.
And by the way, hang
dark.
on. So if you're going by darkness, meaning the absence of light, you can still have a shadow. It's called a radar return.
Oh yeah, yeah. Outside of a visible spectrum, you've got a shadow.
And
Yep.
when you say light, you need to be a bit more specific. Are you talking about visible light, or are you talking about the entire electromagnetic
spectrum?
No. We're talking visible light here.
Yeah. Okay.
Yeah.
Well, then you can still have shadows because there are other parts of the electromagnetic spectrum that can cast a shadow in the absence of visible light.
Okay, then let's get rid of all the spectrums. So now we've only got dark.
Do we get rid of the autistic spectrum as well?
Yes. I think we're exploring that spectrum.
And in that proposition, if we get rid of the entire EM spectrum, you would have you would have true dark because you would actually have the complete absence of absolutely everything.
Yes, but still, my question hasn't been answered. Does dark have matter, or does dark have rest matter?
No.
Dark is just an absence of light.
Hang on. Let me repeat what I said before I started repeating the word no to you yet again.
No.
If you go by the premise that dark is the absence of light and everything, and you want to get rid of the entire EM spectrum, you are getting rid of absolutely everything. So yes, in that instance, dark would have no mass, rest, or whatever.
Well, there'd be air in that dark.
No, there wouldn't.
Got rid of the light spectrum.
No. He didn't just get rid of the light. He got rid of everything in the EM spectrum, which means he got rid of everything in existence.
But you can't get rid of everything.
But you just did, because you got rid of the electromagnetic spectrum.
But where?
But that's what holds our atoms together.
Can you demonstrate this? Can you show me something
where
there's
not what
nothing?
holds your atoms together.
Hang on. I'm being general here. Don't get all
You're being wrong.
physicists with
being wrong.
I'm doing bandy wrong. Okay, I'm doing bandy wrong. All right. If we don't have light, we can't see ourselves.
What's more to the point is any matter at any temperature other than absolute zero emits electromagnetic radiation.
So again, by getting rid of the entire EM spectrum, you are getting rid of quite literally everything.
How do we know that, Jared? How do we know this?
Again, because we know how to measure the EM fields of objects, and we can directly quantify that.
Okay, then. We know how to measure it. I grant you this. We know how to measure it, but have we measured nothing?
Hang on. By the point of nothing being a vacuum devoid of as much of the material as we can, yes, we have tried to measure it, and the results have come back zero.
So basically, we haven't done it.
I think we need to resort to Riley's ice cream maths here. Then, right?
No.
So if you've got,
hang on.
Not finished yet. No, I'm not finished yet.
He misrepresented my answer.
I did not.
He misrepresented my answer.
Bandy. So if you've got 4 ice creams, right? And they weigh 100 grams each. Okay.
Yes.
And then I take those ice creams away from you, and I call that no ice creams. All right. So we've got ice creams, and then we've got another thing called no ice creams. Well, how much do the no ice creams weigh?
So if I've got 4 ice creams and every ice cream weighs 100 grams, so I've got 400 grams worth of ice creams.
Yeah. Now, how much do the no ice creams weigh?
What do you mean? How much of the no ice? I don't have any ice creams.
That's right. How much do they weigh? How much do those no ice creams weigh?
Well, the ice creams would weigh 400 grams.
No, I'm talking about the no ice creams.
Oh, the ones that I don't have?
Yep.
Yeah, well, the ones that I don't have weigh nothing.
Good.
Right. There's your answer.
That's exactly what dark is. Dark is the absence of light.
And this is just proof that
weighs
you're all
nothing.
bullies because you know about taking ice creams away from children.
Exactly.
Oh dear.
You'll get your ice creams back, Bandy, later.
Yeah, and Bandy, if you take your ice creams too close to the sun, you won't have ice creams.
Yeah, and no, Jared,
You'll have melts.
Yeah.
I didn't misrepresent you.
Yes, you did.
No, I did not.
Yes, you did.
No, I never misrepresent anyone.
What was the answer that I gave to your question of has it been quantified? Has it been measured?
You said almost, and so then I said
He said it has.
No,
he said it was measured in a vacuum that had basically no matter in it.
Yeah.
It had almost nothing in there.
There's no such thing as a perfect vacuum.
That's not my fault.
Exactly.
That's not my fault. There's not a perfect
Exactly.
vacuum.
But here's the thing. When you get to as close as we can technologically get to the perfect absence of everything, guess what the EM readings within that area come back with?
I'm going to say that the equipment...
A result smaller than the sensitivity of the device, meaning nothing.
They can't measure it because they haven't got a tool to measure it. That's not my fault.
We have a tool to measure it.
No.
How accurate does it have to be, Bandy?
Well, obviously very accurate.
Okay, to what degree?
I'm going to say 10 to the minus 17 torr.
Is that all?
I don't know. I reckon it's going to have to be pretty damn accurate.
I would say close to about...
With lots of zeros.
You're actually closer to 10 to the negative 98, if I remember.
There we go.
Correctly.
I was pretty close.
Actually,
negative 17 is nowhere near negative 98.
Oh, come on. It's only like about 70 odd off.
Jared.
Thereabouts.
It's actually 1.6 times 10 to the negative 31.
There we go. See?
31?
There we go.
Yeah, that's Planck length.
Yeah. I was going down to true nothingness. When you start dealing with the Planck, it's
it's tiny.
You can't presume what nothingness is if we haven't measured it.
Bandy, I just gave you the increment of basically nothing.
The increment doesn't mean we've measured it.
You can't get any smaller.
That's not my fault. You keep on putting the burden on me.
Yeah, you keep saying we can't get any smaller, but many years ago, we didn't know what size an atom was. We thought that was the smallest molecule in the universe. Now we know about electrons and neutrons and protons. So don't say that we can't get down to these things. It's just we can't do them yet.
Do you know how far past a quark the Planck length is?
That wasn't my point. Why are you misrepresenting it?
Exactly. It's always the globe
doing a Kaiser on us.
Representation. That's what they do. The globe is always misrepresent what we say, Dave. Always.
Yeah, they and them pulling the Kaiser Sose.
G'day.
Answering a question that wasn't asked is known as doing a Kaiser.
A Kaiser? Oh my God.
Sose or cube?
So now we're just going for all out insults from the Globies.
That's what it looks like, doesn't it, eh?
I just watched it. I don't know whether anybody's watched it, but has anybody watched Conspiracy Cat's latest video where he went over what Jose did to Quantum Eraser and Nathan Oakley?
Yeah, that was brilliant. We watched it yesterday.
I thought it was fantastic. Just 3 simple questions. Can you answer any of them? And it just turned into insults and shouting and swearing. It's like, come on, just at least try and answer one of these. Come on. So, Bandy, have you got any answers to those simple 3 questions?
Okay, ask me the questions, Dean, and I always give you an answer. Always. Fire.
Question 1.
But to the questions that I'm going to ask, I know y'all give me an answer. I just don't know when you heard the question to the answer that you gave me.
Yeah, no. I'll answer them.
Okay.
Ask away.
So first,
Question 1.
I thought Dean was asking me a question.
No, it's all right.
Yeah, I want to ask this one. Do you have a photo of the flat Earth?
Do I have a photo? No. Well, I've got a photo of part of Earth. But the whole Earth, no, I don't.
Let's rephrase that. Has anybody taken a photo of this body of Earth that we are on, flat or curved, that supports the assertion that the what we're on is a flat plane? Has anybody done that and said, here is positive evidence for the flat Earth because this does not fit your heliocentric sphere model?
No, because they're hiding the truth. We're being censored.
No, I'm saying, has anybody else done that? It's very easy to do, incredibly easy. All you need is altitude and a camera and maybe a theodolite or a plumb bob or anything, and you can actually do this yourself.
Yeah.
Or you do it with equipment whereby you've got a straight object in view of a lens to take out barrel distortion. You photograph the horizon in the middle of it, and you can see that it's curving at distance. So has anybody said, hey, look, I've done all this and it's flat? Just one image.
Oh, there's plenty of pictures of the flat Earth.
Does it come with
support
data?
the assertion, that support the assertion that the problem with all the images that you claim are the flat Earth, oddly, they all fit perfectly well on a sphere Earth as well.
Well, that's what you keep on saying, but water doesn't bend around the outside of a ball.
That is correct. That is correct. And also, clowns can speak every language and drink glasses of the sun.
That's right.
The two things that we've just said are completely irrelevant. So I'm just saying the most,
Yes,
but
no.
Your bendy water is irrelevant to the question.
Answering your question, no, I don't have a picture.
Right, that's brilliant. So no one, it's really odd. No one does. Not the whole Earth, but something that proves that it's flat. No one does. That's a bit weird, don't you think?
Well, I don't know. I think all flat photos prove flat Earth.
Except when analyzed and they show that they're not actually flat.
What photos are?
Mhm.
Photos are flat as a tack.
No. So if you go up 400 feet and photograph the ocean on the horizon, and you put a straight object in front of the lens, and you line it up with that horizon, you can see that horizon is curving, and it curves exactly the amount that you would expect if you were on a big sort of sphere in a heliocentric model.
Yeah.
So the weird thing is, every time I've seen one of these images, and every time this experiment's been done, it supports a sphere. What I'm saying is there any positive evidence that doesn't support the sphere and supports a flat Earth?
Yes. The fact that I've never seen a photo of curve from back to front, I've only seen apparent curve left to right. There you go.
How are you going to see curve from front to back?
Exactly.
That makes no sense.
Do you understand the difference between a direct and indirect observation?
Direct and indirect, I understand, yes.
Can you explain it to me then?
Why? I said
because
I
I
understand
make
it.
sure that
This
you
is
can
a
actually
primary school. I'm not falling into these. Can you explain this and give me the definition of those? I don't play those games, Jared.
No,
Okay,
wait a minute,
let's get back.
Bandit.
No,
The issue is Z, or depth-based curvature, from an observational standpoint, you would be able to see if there was uniform textures on that surface and the curvature was extreme. Without those two, and I'm talking extreme curvature, from a depth sense, you wouldn't be able to discern curvature.
Oh, that's a pretty bold statement, Dean.
It is coming from a 17-year veteran VFX 3D artist.
Yeah. Oh, yeah.
I will stand by that statement as well.
I know you do. You stand by all your statements.
Now that Bandy's successfully deflected from the three questions, maybe we can ask him the second question.
Well done, Bandy. Well done. I'm impressed.
But actually, hang on, we just have to clarify. We did get the answer that no, there is not a photo of the flat Earth.
Right, second question.
I told you I'd answer it.
Let's hear the second question.
I forgot what the second question was now. Oh, no, that's it. Right. So no, I'm having to remember back. And I'm also developing and programming while I'm doing this. So I'm multitasking. So, yeah, the second question is, we have multiple calculators and predictive systems that work on the heliocentric model. They provide us with predictions about our reality that we can measure, test, and assert to be true every single time. Can you point one calculator that uses the flat Earth model and predicts anything in our reality with success?
So you want a calculator to predict something, do you?
Anything with success based on a flat Earth model that would be definitive that the Earth is flat.
Oh, yeah. Yeah.
Go for it.
A calculator. Yeah. Yep.
Yeah. Just link one to us
You
so it
wanna-
can show us accurate. Well, basically, Bandy, what it is, it's about saying, I know what phase the sun is going to be in 13 days' time.
Oh, so
And I
now
know that. Right, so that's one. I know how much. I know based on where I am and my distance to the horizon that if I plug them into the Earth curve calculator, a ship is going to disappear entirely if it's 50 foot high at this distance. You know, these are predictive systems that we can use that all work off a curved heliocentric sphere model.
Yes.
What I'm saying is there anything, any one calculator that says, hey, the Earth is flat and this proves it because you can make a prediction, and on this flat Earth math, the prediction is true in reality. Just go have a look because there is none.
Yep. 100%.
Go for it.
100%. Now,
Go for it, because Quantum Eraser and Nathan started just swearing and
oh, I know, but they're
insults
amateurs.
at this point.
Yeah, they're amateurs.
I actually have an answer for that question.
Yes. Well, okay then. A calculation. 345.
No, do you have an actual physical calculator?
Oh yeah,
whether it's a program or
I've got
whatever that can make the predictions of how far a ship would have to go on the flat Earth before it disappears.
Well, no, let's just open that up to any prediction that we can baseline and measure against reality, where the prediction is based off a flat Earth model and our reality, when tested, the two match up and support each other.
Yeah. Well, basic Euclidean geometry calculations will predict.
But that's not a calculator.
Well, yeah, you can punch those calculations into a calculator, those numbers into a calculator, and work stuff out.
Give us an example. Give us an example of a Euclidean calculator that makes a prediction based on the flat Earth model.
Oh, yeah, I know. I made a big claim there, didn't I, Paul?
Yeah, that we can measure against reality and prove that this flat Earth works. Yeah, go for it.
Bandy
knows that I can put him under the pump in one sentence.
Yeah, that's all right, Paul. I enjoy it. Now, I can predict that if I build a road from point A and I wanted to go to point B in a straight line, if I use my calculator and put in the right things, I will get a straight line on a flat surface.
Right, so wait a minute. That does not give us a prediction of a system that would allow us to baseline it and measure it against reality. You're asking, you're actually saying there, I can build something to support what I'm saying. No, I'm saying don't do that. Look at reality, look at the systems in play, do the calculations based on a flat Earth, and then measure it, those calculations and predictions against reality.
Okay, then.
They never match.
Okay, can I ask you a question before I answer?
Only if it's quick. Yeah, go for it.
Okay, then. Why do I need a calculator or a calculation of some sort to predict when ships are going to disappear bottom up, or when the sun might rise and then the sun might
so the simple answer of that is a model, as in a mathematical system that represents reality in this case, gives us predictive power when we input variances such as magnitude of things or the passage of time, for instance, which then allows us to look at what we've modeled and say, well, is this model accurate? I know, let's wait 13.5 hours and see, because our model says this, and lo and behold, reality matches. That's all we're wanting. Doesn't matter whether it's the position of the sun, the moon, the crescent angle on the moon based on geographical location. When you're looking at the moon in where you are right now in Australia, the same moon that I'm looking at, the same object, and our crescent is a different orientation.
I know.
Predicted entirely by a sphere.
But why do you need it? Why do you need it though, Dean?
Okay, I'll answer that for you, Bandy. Okay, the short version of that is that a calculator, being a predictive model, allows us a means by which we can falsify our model, okay? Because what we can do is we can use the calculator to make a prediction, then we can go out and see if that prediction matches the reality of what we see. And by that means, we are able to verify or falsify our model. So unless you've got some means of making some sort of prediction, you can't falsify your model. So what we're asking you in a sense is, give us a way in which we can falsify the flat Earth model.
Why do I want to give you guys ammunition to falsify the flat Earth model?
Because that's
how you verify it.
That's right. That's
how
what
science works.
Exactly. That's how science works. That's how we gain knowledge.
Right. Now, before we were able to predict...
No, Bandit. This is, again, I'm just going to stop you. As much as I like you and you know that, you are deflecting. So the point here is we just said that the way we would prove that we are not on a sphere is we build a model, we test it against reality to falsify the assertion we are on a sphere, or the hypothesis that we're on a sphere.
Yeah.
Now, when we start to do the same exercise for flat Earth, guess what? It doesn't work, and it's easily falsified.
I know. And
but it isn't when it's a sphere, so we do that with calculators. With predictive power.
Before you even ask the question, that I don't have such a calculator.
Okay, so yeah, that's a good answer though. You don't have such a calculator. One doesn't exist. None has ever been created.
I don't have that. You don't have. I don't have one.
Okay, it's time for me to throw my hat in the ring for this question. This answer. Okay, one was, why do we need the calculators? Well, okay, so crops to grow, animals to carve.
No, you don't need it. You don't need that at all. No, that's false.
What? You don't need calculations to work out when to plant your seeds to get the best yield from your crop?
Not at all. Not at all. Not at all. Never used it.
Yeah, we've been planting crops a lot longer than we've had a model, any model of the spherical Earth.
Sorry.
Hang on, they and them. We have got better yields because we have learnt when to plant correctly using calendars.
No.
False.
False.
I'm sorry, but there is not one farmer that plants a crop because of a date on a calendar.
That is absolute rubbish.
I'd agree with that.
That is absolute rubbish.
Yeah, my best mate's a farmer, and he does it based on weather patterns. Which in England, he's actually said in the last 2 years, he's in the last 10 years, he said it's just completely all over the place. He can't predict it. He's sometimes got hay laid down that he expected to get baled. That's been laid down because it's wet, because we've just had 3 weeks of rain and it's destroyed like tens of thousands of pounds worth, because you can't dry it. It doesn't dry it, you can't bale wet.
So that means his model that he's learnt over several years of farming has failed because of changes in the weather. But he had a predictive capability of his own from his years of farming.
Demonic, don't take this the wrong way, but you're going down a completely wrong route with this argument. Because farming is...
Guess who has a calculator that works out flat Earth? Walter Bislin.
Bob Super Noodle Doodle?
Walter Bislin has a calculator that will transfer our globe stuff into flat Earth perspective.
Yes, however, there is no such thing as flat Earth perspective, and if you look at Walter Bislin's work, that was done as a parody on how it could work with personal domes and some amazing invented optical distortion.
Oh no, he's actually got it on his calculator.
Yes,
click the button
and it does not match reality.
No,
and it does not match reality.
Yeah, it will tell you nothing.
Oh yeah.
You click the button, it tells you nothing, but it is a calculation for flat Earth.
All right, Dean, you got question 3?
Oh, I forgot what question 3 was.
I think it's probably about a model.
No?
Does
anybody remember what Jose's question 3 was?
Did they even get to it?
Yeah.
I think, well, at this point, Quantum Eraser was screaming retard and doing funny voices like, it's like, is this a grown adult?
He did get to his 3 questions.
I'm gonna have to have a look and see like that.
Hey, I told you I'd answer them, Dean.
You have answered them saying I can't answer them, so technically you're correct.
Well, technically, I'm correct. But I tell you what, how much time would you give me and resources are you going to give me to make this calculator?
You shouldn't need a lot at all. So, for instance, an example here is you should be able to do a predictive system based on elevation and horizon distance. And it doesn't matter whether you think that is a curve, or you think it's based on atmospheric distortions, or you think it's based on atmospheric density and opacity. You would be able to build something with predictive power to measure what's to predict what's there, and see if it matches up with a flat Earth, and then build a calculator on it. But you just can't. It doesn't work. And that's just based on getting a theodolite, or even some optic telescope and a plumb bob or something to measure drop angle, and just doing it at different elevations.
Plumb bobs.
A tube with water would do. A tube with full of water turned up at either end, so that you can approximate that you are level, and what the down angle would be. So most cameras have, well, some of the newer cameras have accelerometers which actually give you a rotation.
So are you saying now rough enough is good enough?
I'm saying that the variance of error that you would get wouldn't be big enough to support a flat Earth. So yes, it is rough in this case, because of the magnitude of the observations would be okay.
Okay.
Crickets.
Crickets.
Oh, someone's ringing the doorbell.
Hey, Sean.
So Khalid had made a working model of the flat Earth at one point, but the flat Earth has already started tearing it apart because they can't agree on their own model.
Yes, I remember that.
Well, I made a flat Earth model and tried making things work, and I invented some amazing physics to make it work as well. Like, what did a fractured light?
I remember. I remember.
Yeah, I had to invent that, didn't I? And I thought that was cool.
And fourth power, third power.
Cubic energy fall off,
yeah,
and quadratic energy fall off as well, that we haven't discovered yet because of some other thing that we haven't discovered yet. Yeah, there you go.
Actually, I have an amendment to my calculations of crops. They use it for yield production. They use it for row spacing. They use it for crop loss. They use it for other estimates and for insurance purposes.
Yeah, I think you can actually use it in good climate or constant climates, but for things like, I would say, at the near anywhere moving away from the equator, it just the variances now in these days, not 100 years ago, but these days, has become really, it's almost pointless to use now. So, for instance, I had snow in the summer 2 years ago. And it lasted. We had a chill. We had a Siberian front coming because of a change of weather conditions from the Arctic regions and North Russia. So it's crazy at the moment.
I happen to live in the driest state and the driest continent, apart from Antarctica.
Nice.
We don't know what snow is.
But also, that wasn't your claim, Demonic. It was the fact that you claimed that the model predicts all these things. That's experience that comes from the point of view of your crop densities and everything else to increase your yield and make it as efficient a system as possible, though, not from a calendar or a model.
Yeah, but isn't using your experience basically calculating things over the years in your head?
Yes, but you said a calendar, and that's where I was correcting you, because it's not a calendar.
Yeah, but also wouldn't the farmer over the years have gone, okay, this time of this month is when I should start doing my rows, and this is when I should start planting, or this is when it's possible to start planting, or this is when I expect the rains to start coming?
Yes, but that comes from the experience of the farmer. It's the same as if you go to with an engineer and you go to do an apprenticeship. The old timers will know a hell of a lot more than the guys that are just walking in out of university.
True, but you still, for a farmer, they are going to build a calendar to tell them when to do stuff based on probably
I'm pretty sure they don't.
of the year.
From the farmers that I've spoken to, don't actually have have calendars as such. They would know from experience roughly what part of the season. But it's still purely exactly what they and then were saying. It's purely based on weather conditions and temperature and all that kind of stuff. So most of them wouldn't really base it on any kind of calendar. Really, it's just purely out of experience. Because don't forget, I mean, yeah. I was just going to say something stupid then. So I'm glad I stopped.
They also
myself.
too use the moon, the phases of the moon, to tell them what was coming up, when to start preparing, that sort of stuff.
Not heard that myself.
Yeah.
Well, I say the which the full moon after the middle of winter. How many full moons after the middle of winter are you going to think about doing this? And
yeah, that's right now.
Because yes, experience tells you when to plant it, but you still need to. You still need to know that it is actually that time of year.
But you know that already. You don't need some predictive thing to tell you that.
Yeah, I mean, all farmers know exactly what crops they've got and roughly when, what part of the season, roughly, when it's going to be sown. But it's purely judged on temperature and weather and all that kind of stuff.
Yeah, exactly. Like the predictive calculator that you might want to use for this might say, okay, then get ready to plant your crops on Monday. Now, come Monday, it could be terrible weather, right? Too much rain, not enough rain, whatever the case may be. So you hold off.
Yeah, but it's not planned months in advance. It's exactly what date they're going to sow it on. Say do a particular job or whatever they need to do.
No. They're sowing by season.
Yeah. Yeah, it's only an approximation.
Yeah.
And I think the real point here is those things, even though they might be based on a calendar and repetitive cycles and stuff like that, even though they knew what time of year to plant things before the calendar was invented, none of that really has anything to do with knowing what shape the Earth was. So all of these knowledge about cycles and where the sun was at a particular time of the year and stuff like that didn't have anything to do with the shape of the Earth. They were all cycles that they gained from making observations and through experience and stuff like that. But none of that told them what shape the Earth was. So you're not really answering the question with that calculation. It's not based on a flat Earth model. And that's what Dean was asking. He was asking, do you have any calculators that are based on a flat Earth model that allow us to make predictions? So no, those predictions based on the calendar aren't necessarily to do with the flat Earth model. So it's got nothing to do with the question.
Yeah, so here's an interesting thing, Bandy, is I made a few 3D models, and I made one of our solar system and stuff, and I put the moon phases in there and made it so that I could rotate around and progress time and all that kind of stuff. And then I put different cameras in there for both the flat Earth and the globe Earth. And on the globe Earth, I put a camera in South America, Argentina, I think, and I put one in my hometown, and I put one where Jose is in Florida. And I was looking through my camera, and I looked outside at the moon, and I thought, yeah, that's cool, wicked. And then I looked in Argentina, but this is how silly, and I'd never thought of it before in my life. And I looked at the same kind of moon from Argentina in the same day cycle, and I saw that the crescent was actually at the top. So I was in northern Argentina, I think, and the crescent was actually at the top of the moon. And it's like, oh my God, I've never seen a moon like that in my life. Obviously, it's going to be like that on a sphere. So even me just doing that model is something that I'd never thought about. If you'd have asked me I'd have had to think about it, and logically I would have come to that conclusion. But in making that model of my perception of reality, I learned something that then the first thing that I did is I went online and I looked at views of the moon from Argentina, or northern Argentina. And I saw that the crescent was angled and a bias towards the top, and that's something I've never seen in reality, which is amazing to me.
Yeah, I get that down here in South Australia too.
Yeah.
The top of the crest is actually angled over.
And then I also noticed one last thing that model that never struck me before, and that's the fact that the tidal locked Z rotation of in relation to me of the moon goes through a rotation with the axis from my eyes to the moon, and it only does that because I'm on a sphere. It would not do that on a flat Earth.
I'm glad you mentioned the tidal locked moon, Dave.
Here we go.
I'm so glad now that I did as well somehow.
Actually, that reminds me of the name of one of my videos. It's actually called Flat Earth Misunderstandings.
Now,
words that Flat Earthers misunderstand.
Righto, Bandy. Go.
Now, Dean. Now, be quiet, Paul. So, Earth has gravity, yeah, Dean, and the moon has gravity, and they're tidal locked.
Wait a minute. It has gravity. It generates gravity it generates a gravitational field due to its mass. Yes.
Well, it either has it or it doesn't has it.
Yeah, but it's not like you can pass it on to something else and just say, "Hey, I have my gravity." So, but anyway, go on.
It's not a packet of boiled lollies.
Yeah. So anyway, go on.
All right. So it's tidal lock. So we've got these two forces acting against each other. So we've got the gravitational force of the Earth, apparently. Okay. Okay. So just remember the word apparently, because I won't use it from now on. All right. But apparently there's the gravitational force of the moon and the gravitational force of the Earth. Right? The gravitational force of the Earth is stronger. Agree? Apparently, because there's more mass. Yes. All right. So we have one force that is greater than the other force.
Correct.
All right. So we have two forces that are acting with each other. Okay.
Correct.
And are attracted to each other.
No, because the Earth and the Moon have, from the Earth and the Moon's point of view, have equal and opposite forces acting on them.
Well, no, it's just on about gravity at the moment.
From their mutual gravitational fields. Because you can't consider one in isolation. You can't consider the gravitational field in isolation. You have to consider
the
gravitational field as a two-body object.
Well,
no, you can, but it's the fact that the calculation for the gravitational field incorporates both masses. So,
but that depends on relative standpoint as well. It's not an absolute. Yeah. So anyway, I'll jump forward to your answer, Bandit. If both planets were stood still, absolutely. Or if both bodies were stood still. Can't believe I just called the moon a planet. If both bodies were stood still, then yes, absolutely. They would be attracted to each other and collide.
No. See, it wasn't my question.
Oh, go for it then.
Because there wasn't a comma or a full stop or a colon or anything. But I'll continue the question.
I know where you're going, but I'm not going to interrupt you, Bandy.
Yeah, I know.
And so I know where you're going, but I'm not going to make an answer.
And Paul knows where I'm going too.
I've never heard this, so go on.
Oh, you haven't? Okay, it's a good one. It's a good one.
So now we've got two forces that are acting upon each other. All right, and the Earth rotates, spins, whatever you want to call it, faster than what the moon does. All right. So we have one force that is spinning faster than the other force. So then
stop right there. Stop right there. So when you say spin, are you on about spin around its own central axis, or the point of where we would say the gravitational axis is?
I'm talking about
so like the Earth rotating in a day. Sorry.
No.
Rotation. They're two separate things.
On its own axis.
Okay, that's cool. Yeah. So you understand that spinning. Yeah. So you understand that a spinning Earth, the gravitational or the energy or the magnitude of the attraction doesn't change just because it's spinning. right? So
No, I'm not saying no. It's the same. It's the
yeah.
same.
Okay, that's cool.
Yeah. I know. Yep. Let me finish my question. Right?
Cool.
You got to let him finish. You have to.
All right. So then, why doesn't because of fluid dynamics, all right? Why doesn't the moon move in a counterclockwise direction? Because you have that force of the gravity, right, spinning around, right, acting against the moon. But the moon, apparently, we only see the one face, but it doesn't move in a counterclockwise direction.
So gravity does not spin. An example of that. No. Listen. So gravity, the weak force, does not. The fact that the object that is generating the field, that field has uniform vectors that do not change based on the spin around its own axis. And the way that you can figure this out is with magnets. So if it's the same reason that if you've got the poles at the top and bottom of a magnet, and then you put something on the actual magnetic plane, spinning that doesn't cause the magnetic effect on the affected object to spin. That's not what it is, because the magnetic field that's the gravitational field that's generated is not a fluid. It's a field.
No.
Not like water.
No, of course it is.
No, it isn't.
It's fluid dynamics. It's the same
No, it
principle.
isn't.
You got
Look, I know Navier-Stokes equations based that are the predominant mathematics used in fluid dynamics, and it is not.
Yes,
I promise you this.
No. You have two forces acting upon each other. They're locked. They're locked together.
They're not two separate forces, though.
No. Well, in this case, Alan is on about. Well, we're on about a centrifugal force here.
They are two separate forces. They are two separate forces. They have to be two separate forces.
How can they be two separate forces?
The short answer to the question, Bandy, is that the force vectors aren't rotating sideways.
Paul, you've already explained it to me. Shush.
Isn't that? Wait a minute. Isn't that exactly what I just said? In the field, the vectors don't change due to the rotation.
That's right.
You can't change that. It's the same in magnetics.
But they have to spin.
Can't change that.
They have to spin.
Bandy.
No, they don't.
The
No, they
Earth
don't.
is
Wait a minute. Here's the thing. Can you do that with electricity? No.
We're not talking electricity. We're talking gravity.
We're talking about an energy field.
We're talking about gravity, a force.
An energy field, correct.
It's a force, all right?
Dean.
A field that can exert energy.
Dean,
Dean.
that force is created by the mass of Earth, correct?
Dean,
Correct.
invoke space-time.
Okay, then.
No.
So if gravity is caused by the mass of Earth and that mass is rotating, then gravity naturally has to be spinning.
No.
What is mass?
No,
Paul.
What is mass?
because we just look at a point. Because when we do Newtonian gravity, we always look at point sources, and a point doesn't matter if a point source rotates.
Yeah, no,
Sure.
but it's easier explained, Bandy. Is my answer to that is what is mass?
Well, what is mass?
Yeah, that's what I've just asked you.
I know. What is it?
And the matter that makes up the mass, and the mass is centered around a center point. Does that change if we rotate a sphere?
Has to.
Or does it stay equidistant?
No, it has to change. If the center point is rotating, spinning, right, then gravity has to be spinning too.
No, you can do this with magnets.
We're not talking magnets, we're talking gravity.
It's a field, it's an energy field.
No.
Bandy,
with
Bandy, I've got a
vectors.
question. I've got a simple question for you, Bandy.
Yeah,
If
mate.
I've got a clear crystal glass sphere, no markings on it whatsoever, and I plonk it down in front of you, which direction is it facing?
How do I know I can't see it? It's clear.
You can see it because you can see light reflected off it.
Oh, okay then.
But if I put it down in front of you, which direction is it facing?
Well, which is the front?
How do you know?
That's what I'm asking.
Yeah, well, I'm asking you, how could you tell which is the front and which is the back?
Well, you'd have to put a mark on it, wouldn't you?
You would, wouldn't you?
Yes.
Okay. The point is that the gravitational field surrounding the Earth is indistinguishable. It has minor variations in it, but the fact that the Earth rotates, if you take any point in space and make the Earth rotate, okay, that same point in space that hasn't rotated with the Earth, the gravitational field is going to be the same, regardless of whether the Earth is rotated or not.
It doesn't.
So something very easy to grasp though, Bandit, is conservation of momentum only works with does not work with a field, and that's what your argument is here. You're saying that the field or the force vectors of this field, because what's generating them is spinning, would no longer point to the center point of what's generating that field. And that would only be true if conservation of momentum came into it, and you would perturb those, you'd change the direction of those fields. But that's not how an energy field works.
It doesn't make sense that the object that creates the force of gravity, the object itself, if that object that is creating that force, because it's an object, is rotating, then that force isn't rotating with that object. It doesn't make sense.
I am gonna do what someone said and go to
Bandy, if
space time and just call it a gravity well. So forget the Earth being here. The fact that the Earth here is incidental. By cause and effect, somehow, the Earth is creating a gravity well at the center of itself. Oh, wait a minute, got someone at the front door.
So Bandy, you're trying to say that the Earth's gravity and the Moon's gravity are attracting to one another, which is creating an effect. Now,
Yes.
Wouldn't that also mean if Earth's gravity and Moon's gravity is attracted to one another, wouldn't the Earth be attracting the Moon closer to the Earth?
Apparently, it should be, shouldn't it?
So why hasn't it? Why hasn't the Moon? It hasn't hit us yet.
No, not yet.
Because we're
But isn't
going
it?
round and round each other.
It is
and
getting closer though.
that
isn't it?
gravity equals the centrifugal forces on both bodies.
Centrifugal.
Yeah, but isn't the Moon getting closer?
No, it's actually getting further away, Bandy.
It's getting further away. Is
Yeah.
it?
So
It is
Okay,
moving
then.
away.
No,
So then-
I definitely. Whoever said centrifugal, no, I definitely meant centripetal.
Okay then. So then we know that there are forces then acting upon each other. Then don't we?
Centripetal, isn't that a pulling force?
So then if we've got
Yeah.
centripetal force acting upon it, it would be moving in an anti-clockwise direction.
Oh yeah, sorry, that was me, Alan, and yes, you are correct.
A counterclockwise.
But Bandy, what you've also got to understand is whilst the Moon is orbiting Earth, there are...
Earth is orbiting the Moon.
Yeah, but there's also 7 other planets and a sun that you have to take into account.
Yes, we do. I've got no problems with that whatsoever.
So you're essentially saying that there should be a sideways force on the Moon. Then?
No, I know what is missing here, and I hate to say it, but what you're missing is the ether. That's what you're missing. If we could just prove that, Bandy, you'd have some validity to your argument.
We were talking about the ether band before. You missed that conversation.
So you're saying that the ether's not just in our atmosphere, but it's also out in space?
It's everywhere.
That was the hypothesis, yes.
Well, our Earth's atmosphere does extend to the Moon.
The ether band is everywhere.
No, it's not the atmosphere. It's just particles.
Is it ether already? Is it? When's the ether bunny coming?
Mm-hmm.
Sorry.
The ether bunny.
The ether bunny, yeah.
The ether bunny
Terry?
that drives the
ether van to ether band practice.
I didn't think it was ether already.
Oh God! Don't make
Yeah, we're gonna get past Christmas.
By the way,
me laugh out loud.
just a quick thing,
Breaks my
Bandy.
face.
The last question, I think, from what I've just looked at, was Jose showed some images and video footage that are examples of curvature by ships going over the horizon, by the sun going over the horizon, things like that.
And
that
his lighthouse.
and his lighthouse, which
Yep.
match reality.
Mhm.
And match a curve calculator. But he says, is there any video or photo evidence of no curvature? In other words, something going away that doesn't go behind the horizon.
Well, how far away do you want to see something?
On the z-axis, which is the one that runs directly in front of your face and out, is there a picture of something on the flat Earth that disappears bottom up?
Yeah, plenty of pictures.
No. It's probably better to word it.
Yeah.
And obviously, it's dependent on your elevation or the observer elevation. But I want the evidence that he would be looking for there would be something moving away and not transforming or translating downward as it goes over our curved horizon. It would need to stay constant, which would easily be worked out with laws of perspective. You see, the problem with some of the ship going away is, yes, I don't care that it's hidden by the bottom's hidden. That doesn't interest me as much as the fact that it disobeys the laws of perspective on a flat plane, and it starts to curve downwards.
No, you've got shoaling, you've got perspective, you've got angle of attack, you've got the ether band, you've got so many things that come into it, Dean. Come on, that's
Bandy, what he's trying to say is that on our model or our planet, as the ship goes away, it will disappear behind the curve before it shrinks out of view.
Yeah, but we know that all the pictures that you show are all on a flat plane, so there's plenty of evidence.
Yeah, but they don't support the fact that it's a flat plane.
No,
they support
no,
the fact
no,
that it's
no.
a sphere.
No.
Or the assertion that it's a sphere.
All those photos support is what you see in reality.
Yeah, and in reality, things geometrically curve away and go downwards.
Well, then why does the horizon rise up? If I was living
horizon,
on a ball, the horizon would go down.
The horizon does not rise up at all. That is a misconception. Okay, that would be another thing. Prove that the horizon rises up, and you've got it. You've won.
Of course it does. It comes up to near my eye level. There it is.
No, your eyes dip down 2 degrees.
Yeah.
It's that simple.
I said near. I didn't say exactly.
So the point here is everybody that's tried to prove that what you've just said is true fails in a spectacular fashion.
How come when I'm looking at a floor along a hallway, the end of that hallway seems to rise up?
Seems. Why don't we chuck seams out?
Go.
And actually, wait a minute. Yeah. It seems like, in the distance, that building is made of jelly.
Yes.
Am I to assert that building is made of jelly, or should I actually figure out the actual reality of the situation, which is it's made of solid brick, and the air and refractions through the air is causing that to happen? So yes, it might seem that, but what I'm saying, Bandy, is all you need to do is prove it. Not, hey, I've got a feeling. Hey, it seems. You just need to prove it. And the way that you prove it is you take something that can measure the fact of whether it's level or perpendicular to the ground, and you go up in altitude. You can do this with a pipe, clear pipe and water. And at a couple of 100 feet, you can realize, oh, hang about, this doesn't happen. It just seems to happen when I don't measure it.
Okay then, Dean. Yeah. You are the CGI expert. We know this, right? Can you show me a picture where I'm standing on top of a ball, right, and me looking out and that horizon rises up?
Yeah, just tilt the view camera down a little bit every time I go somewhere else, and that's what naturally you do.
So you've got to completely...
Put it this way. The way... Are you ready? Here's a brilliant assertion. What about if we say that, no, I'm going to tell you that it doesn't seem that way. But guess what? In order for it not to seem that way, my eyes would need some kind of leveling instrument that automatically biases them to be perpendicular to the ground.
Yep.
So the only way the horizon would not rise to eye level is if somehow, biologically, I had a system and mechanically had a system that meant my eyes always were straight and parallel to the ground. And that is not the case. My eyes are seldom parallel to the ground. That's not what we do. We are focused on the ground. We don't suddenly walk up a hill and look straight forward and think, great, I'm going to carry on looking at this sky to make sure I know where I'm going. We do not do that.
No, you got to look. You got to mind where you're walking.
There you go. We look at the
keep an eye-
ground.
Yeah.
Our eyes are drawn to the ground because of how we actually want to perceive the world around us. We don't think. Yeah.
Exactly.
So it seems like that happens.
That's right.
Because our eyes dip down.
And,
Yes.
and
If
Dean,
you test and measure it, you realise it doesn't happen, and you can
Dean,
do it with
do you want to
water
know-
and a pipe.
do you want to know how good our eyes are at being independent from everything else in our body? At the moment, because of the Bell's palsy I have, the entire right side of my face is paralysed. I can't blink. My eyelids don't work. I can't blink. My mouth doesn't work. My tongue doesn't work. I can't taste anything. I can't sniff. I can't blow the right side of my nose. Nothing works. Yet my eye still whizzes around inside my eyeball.
And the weird thing is, you still sound less drunk than Bandy.
That's harsh, Dean.
I'm sorry.
I thought
Hey,
we were
Dean.
friends, Dean.
Dean, would you like some numbers?
Numbers. I love
know,
numbers.
numbers
I actually
of-
hate numbers at the moment.
Well, actually, these are easy numbers. Okay, you know how Bandy said it almost goes to eye level when he's standing on the ground?
Yeah.
Okay. Well, that actual drop is 0.004 degrees.
Yeah.
Okay. So, and that's at about 5'9". Okay.
Oh no. No. This whoever's got this up, is this you at the moment presenting? This is
no,
this is perfect.
that's Terry. That's Terry,
Oh, right,
and
yeah.
his water
This is
levels.
perfect.
Yeah.
We like our water levels because they show something.
Oh, water levels are the best. Water levels are what proves the flat Earth, undoubtedly.
Except you got a problem here because it's not rising to eye level; it's dropping away. Why do you think that might be?
I said roughly to eye level, didn't I?
Okay,
You
so
didn't
it's
say- you
roughly
didn't say
conforming to a
roughly.
sphere.
Oh, I said almost.
Except when it isn't.
Right?
It's the ether band perspective.
Yeah. Almost isn't good enough when it's coming to measurements, Bandy.
Yeah. Water levels, they prove the flat Earth every single time. You know
Except
that, Dean.
except when they don't, like this.
No,
Yeah, like the ones we're looking at.
no. You know that water's flat and level, Dean. Come on, go to a lake, have a look. You don't see big
Don't you
folds in the middle.
remember the videos you watched earlier on in microgravity? What the water was doing? Oh, you've
Yeah,
forgotten
but
that then.
see, we don't live in microgravity. We live here on terra firma.
No, but we showed you on a video earlier on though, didn't we?
Oh, we certainly did, and I enjoyed the CGI. I told you that at the time.
Bingo. Bingo card's full now.
You know, we got them all.
said CGI.
So Bandit, I don't know whether you know this. I'm sure you do, but I know a little bit about CGI. What was the dead giveaway of that fluid in the fact that it was CGI? Or just tell me the experience that you have in able to judge the fact that it's CGI.
Oh, Dean, you know I've got absolutely zero experience in determining that.
So shall we just forget that you said that?
Yeah, pretty much. Yeah. Throw that one out the window. I'm cool with that.
Don't get me wrong. Real time fluid dynamics with encapsulating meshes that would produce something like water is very possible. What isn't very possible is you would be able to tell that it's not true and in situ and real time, because the refractive index of water is 1.3, and it has scatter coefficients and absorption coefficients that are incredibly hard to replicate. But the reflections of that ball are omnidirectional. So the problem in doing it over live video footage is you've got one reference plane. Now, don't get me wrong. Could we do it in real time? Possibly. But what it would require is 6 cameras simultaneously feeding a polarized texture sheet to then apply that as a makeshift reflection to it. Now, with that in effect, we could do it. The only thing we couldn't do at that point is have human beings pass behind it and interact with it. That's not within the realms of possibility yet.
Now, Dean,
Yeah.
do you have a picture, or does anyone have a picture? Anyone, you can pick any trusted person that you like. Doesn't have to be yourself. It can be anyone, as long as you trust.
Yeah, I don't trust myself. No, I don't trust
Exactly
myself.
right.
Go on. Yeah.
And get me a photo of a nice big still lake with a big bulge in the middle.
Right. So here's the thing. The bulge in the middle. What bulge are you referring to?
Well, you know what bulge I'm talking about.
What bulge? There is no
Are you
bulge.
talking about 1 degree of curvature over 69 miles?
Yeah, 100%.
Okay, brilliant. So what do you think in a human perception sense, and bear in mind our field of view is actually quite decent because we can skip around and assemble, we can assemble images and paste them up in the past, and that's how our perception works. So we can pan left to right and our brain is perceiving this huge landscape.
Yep.
But how far away from this curve do you think we would have to be to get a human perceivable geometric curvature?
Well, you could take a big photo, a big wide angled shot, all right, and then you could reduce it down so then I can see it. And you can take maybe 3 degrees.
You wouldn't get 3 degrees over. Do you know any lakes that you would be able to see from left to right over 200 kilometers?
Maybe like
I could give you one that's 177 kilometers.
I've got a number that's going to mess you up here. At 9 miles, the drop is 6 feet.
There we go.
We don't need to go that 69 miles.
No, but we want to just nail this. We want a good.
No. We're on about lateral curvature here. You don't perceive the curvature away from you, not easily.
That's convenient.
No, it's just perception and geometric reality. You do not perceive that lesser curve. And I don't. Yeah, that 3 miles. You're on about what? 0.04 degrees away from you. Yeah, I'm not going to see that. No one is.
Fine.
Especially not in a fractal surface like the ocean.
If I look at a basketball front on, I'm only seeing lateral curve. Is that what you're saying?
I'm on about, in order to see that bulge, you would have to see it laterally, left to right.
Yes.
And in order to see that lateral curve from the left to the right and the extents, you would have to, as a human being, to notice this, see, I forgot what it is. I did it in that 3D model, but I think it might be 4 degrees or 5 degrees of curvature to actually notice it in your field of view. But the problem with your field of view is you have a periphery vision that detects motion and rudimentary color, but not detail, and certainly not geometric detail. You've only got a narrow band of like 40 degrees where you can discern detail. So in order to see 4 degrees in 40 degrees of detailed vision with the human eye, you've got to be, 100,000 feet up or something stupid, or whatever it was. I worked it out ages ago.
Yeah, but I'm talking about a photo. I'm not talking about getting up in a Concorde and having.
Yeah, but this has been done loads of times, Bandit. People have taken photos against a straight meter ruler, lined it up in the center, and you can see the ocean bending. Yeah.
Now, what about from above? Right? If you look at a basketball from on top, you can tell that it's a hemisphere.
Right. Let's change all the metrics of that to be relative. So now let's stand a billionth of a millimeter off the basketball. Can you tell what shape that is?
No. So now let's go up a fair old distance. Say
100,000 feet. 100,000 feet. Let's say. So let's say half a centimeter.
Let's go 30,000 feet.
All right. So now we're at what are we about?
And then we're taking a picture of
10 mil. 10 mil off the surface. Yeah.
And then we're taking a picture of Lake Eyre, looking down on top of Lake Eyre.
Yeah, you would see no curvature whatsoever.
That's what you keep on saying. See, we're not seeing curvature.
Yeah, you're 10 millimeters away.
I know.
With a 40-degree lens from that basketball.
So if I can
you won't be able to tell that it's a basketball.
But if I can never see curvature,
you can laterally left to right.
Yeah, but that's because I look through spheres.
No.
Yeah.
You can see it with a rectilinear lens, or you can take barrel distortion away from it by having a physical straight object in the scene as a baseline. But barrel distortion or pillow distortion, the opposite of barrel distortion, is nullified if you have it in the center of the lens.
So if you're taking a picture of the horizon there, Dean, and I get my 3 meter straight edge, right, and I line it up, and you stand back with your super duper crazy new cameras that you've got there, right, and you take a snapshot.
Paperweight, yeah, my paperweight.
Yeah, your paperweight, yeah. And you take a shot of it, you're telling me that I'm going to see that lateral curve from left to right.
It's a 4K HDR raw video camera, so I wouldn't actually take a photo with it.
Okay then.
But yeah, I'd get one of Alan's cameras and put a wide angle lens on it, something like a 24mm. Or equivalent 24mm, and then take a photo. And yes, in the photo, compressing it down, the ruler would stay straight and the horizon would curve.
Would look like it's curving.
Yeah.
So what?
People have done this. Loads of people have done this.
Yeah, I know.
All you need to do is prove that that is not the case by doing it and saying, "Hey, look, when the field of view on this equivalent full frame, the equivalent 35mm, 24mm lens, look, I compress it down and the horizon is parallel to the straight physical object that I had there."
Well, I've got to go. See you later, ladies and gents. Have a good one.
See you, casual.
Space man.
Actually, Dean, what you really want is a Canon full frame sensor body, preferably the 5DS because it's got very high resolution, and you need the Canon 11 to 24mm zoom because that is almost perfectly rectilinear at 11mm.
Oh, is it? Nice.
Yes, it is a huge
11. Jesus
at
Christ.
11. It's rectilinear at 11mm.
Holy shit.
And it's almost, and there's almost no distortion in there at all. I mean, that's why it's a 2,000 quid L series zoom.
Yeah. Well, yeah. Well, my 2470 cost 1,900 quid when I bought it. I think.
Exactly.
Yeah.
But the 1124 f4, I think it is. Yeah, it's rectilinear at 11mm.
Nice.
And it covers a full 35mm film frame.
Dean, have you seen this photo that I've put up?
I have not, but is that the east coast of Australia?
It's the Great Australian Bight, actually, and it has 2 horizons.
It has 2 horizons. Oh, a land horizon and a thing, and they are slightly different elevations. Nice.
That's right. Which one rises to eye level?
Camera level. Your camera's dipped down, and well, actually, your camera level's like looking at the sea. So neither.
Yeah.
One last one for you, Dean. One last one.
And that's actually curved, by the way.
So these photos that the people get with these straight edges, right? And they take pictures of the horizon and say, "Look, there's curve. Look, this there, and blah blah blah." All right. Yep, granted. But have one of these people gone out and confirmed the depth of the oceans at the horizon?
Why? When water always finds its level.
All right. I've got something more worrying on the rumor mill.
Is that your puppy, by the way?
No, unfortunately not. Riley is going for dumb fuck of the year really hard. Apparently, he has just pissed into a bottle off streaming while still live.
What?
He's just what?
He did not.
Apparently so. That's the rumor that I've just been sent.
No. I missed that because it was a loud buzz just when you said the important thing.
Yeah, they and them had a thing in his mic.
Yeah. Apparently, Riley was just pissed into a bottle off screen while still live streaming.
Really?
So he thought he was offline and he pissed into a bottle.
Not sure what the context of it was.
I think it'd be staying online, not wanting to move, need to go to the toilet, so then just piss in a bottle. That sounds like something they do.
He did not.
You just go.
These are your fellow teammates, Bandy. Well done.
No,
You
no,
just mute yourself and go.
no. I'm a sole rider with they.
You're an independent.
Yeah.
The good thing is you can rewind his live feed at the moment.
Yeah, I am. I'm doing that. Damn.
I'm already on it. I'm already on it.
And I'm not really interested in doing that and watching him piss. Jesus.
It's kind of like a car crash, isn't it? You want to see it. Yes, water always does find its level, Dean. You're 100% right. I'm glad you agree with that.
Oh, cool. I'm watching a flat earther get arrested too. That's awesome.
Yeah, he got arrested for nothing, really. He got bloody accosted.
Well, the problem is you're being disruptive and spreading lies. That's not what society wants.
I was so disappointed I couldn't go and visit them in Norwich.
I think
they came to Milton Keynes and I missed them.
They came to Norwich and it was a bloody Sunday, wasn't it?
No,
so
the worst thing is
bus.
they came to Milton Keynes and they somehow, if you go to a place, you look at where the footfall's going to be. They came to Milton Keynes and stood outside the side of a McDonald's in the shopping centre that no one ever goes to.
So now he's drinking it.
Oh, we should watch the Casual Spaceman live in about 17 minutes.
Oh, it's going live.
We could watch him live on our stream.
Happy days. That gives me another chat to get into and disrupt. I've missed my chats with you, Dean.
Aye.
Well, Dean said he didn't want to get back into flat earth, so talking to you, Bandy, is acceptable.
Yeah, well,
I don't mind it when you're doing a piss take.
Yeah, well, that's why you came in here, wasn't it, Dean? You thought, oh, Bandy's there. Yep, I'm in.
Yeah.
Yeah, we don't need facts.
Lucky I'm thick-skinned.
No, the worst thing is the space denial.
I've never denied space once.
I was disappointed last night because it was cloudy when I needed to take those photographs that I was going to take. So.
Well, that reminds me, I've got to check where the moon is.
Well, you do live in Britain, Alan. You can't, no excuse for that.
And it is late, and it is what we would call late autumn.
No excuses.
Wow.
I've lost a video. Oh, here we go. I think I found it. I hope I did.
I've got to get myself some...
Shit.
The easiest way to actually prove the shape of the Earth is to join a ham radio group that's international that uses the moon to bounce the radio signals, and the reflecting angle doesn't work on a flat plane.
That's because it's bouncing off the dome.
The dome, it wouldn't work bouncing off a dome either.
Yeah, it would. Bounces off the ionosphere and the troposphere. And then it ducks its way back into the antenna.
Bandy, you're so lucky Peter's not here because he'd be on you right now.
You like how I threw the word ducked in?
Yeah.
Yeah, we noticed.
I listen occasionally. Well, peoples, I've got to get some sleep. Over to work tomorrow on a public holiday.
Tomorrow's not a public holiday, is it?
100% it is.
It's Melbourne Cup Day. He's in Victoria, remember?
Yeah. We get all good public holidays. Grand final.
Oh, you have any excuse to have a day off?
Grand final, public holiday on a Saturday.
We get it on a Friday, actually.
Yeah, no, it's stupid.
Yeah.
You should really get it on the Monday to cure the headache that you get from Sunday.
No, Yeah, maybe. But we have good governments. They give us public holidays. Here. So anyway, I'm going to, it's been a blast.
Oh, has it? Yeah, just make sure you get that cup of sun when you go to work tomorrow, all right?
Well, I'm waiting for Jared to help me out there.
Search eBay for plasma containers.
Yes.
No, Amazon. I thought Amazon was better.
A big ass thermos. That's what we need to collect it. All right, guys, it's been a blast.
That's what you say.
Until the next exciting episode. As they say, keep it flat.
Do they say that?
Yeah, where did they say that?
Where do they say that? Where's the citation for that?
Talking of wanting a bucket of sunshine, I remember being shown around an RAF Nimrod and noticing that the pilot had an arm switch for the that was labelled special weapon arm, so that they could go and drop the bucket of instant sunshine in the sea.
Well, I've just seen the size of the cup that he would need to be able to hold just a cup full of sunshine.
Yeah.
What, with a massive EM field generated in it as well?
Yeah, it is. It's huge.
Yeah.
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 All right, guys, I'm going.
Righto,
Next time,
Bandy.
I'll listen to you talking about me behind my back.
Yeah.
All right, have a blast. Ciao.
Bye, Bandy.
Ciao.
See you, Ben.
Bye-bye.
Yeah. It's the experimental tokamak fusion reactor. That'd hold it. A little bit of sunshine.
We talking about this image before? If you compress the horizon with straight edges, you get curved.
Well,
Yeah,
yeah,
but-
that girder's not a true thing, is it?
That girder doesn't look very straight, is the problem.
But you see a nice uniform curve, I think, on the horizon.
Yeah, you still see a curve anyway, whether it's perfectly straight or not. Look, you can see that even on the outside of the picture, you can see that it curves down.
Yeah, but I mean, even that looks like a 28mm lens there. With what Alan said, 11mm, you would get a lot of curve. And the daft thing is, in today's day and age, with that 11mm, Alan, you'll be able to load in a profile in something like DaVinci Resolve and actually just cancel out any distortion that was there.
I don't think it's actually got any that's worth, any that.
Yeah. The 11mm, yeah.
Even at 11mm, it's so rectilinear. I don't think there's been too much need to do very much with it.
Mm.
Hey, look, Dean, do you know what that's called? Bendy water.
I was going to say, yeah, bendy water. I think the easiest thing to say is, can anybody name anything that isn't made up of spheres?
The Rubik's Cube.
It's got matter in it. Those,
Shut
the
up.
matter
Hey,
and the
hey,
atoms and the
don't.
electrons, all spheres. All spheres.
Hey, don't invoke the quark on me.
I was going to say, I thought it all just came down to waves in the end.
Actually, that makes me wonder, are gluons spherical? Crickets?
Makes no sense to talk about matter at that scale having a shape.
Especially if they exist in probability fields.
I think it was Wright the Hand that was asking at one stage, what colour are electrons?
What colour are they?
Not you too.
They're sort of, generally they're sort of pale blue. Did you not know that?
No.
For God's sake, when you let them, when you let the bloody magic electrons out of the circuit, it always comes out as blue smoke, doesn't it? So they must be blue.
Yeah, you got to get that Lucas
But when they
blue
go through
smoke.
the toaster,
Yeah,
they're orange.
Yeah, but that's because they're being made angry.
Oh.
That's because they're being made angry by being pushed through a tiny narrow little bit of wire. If you let them out, they go blue. They turn back into the blue smoke.
I actually have a question for the whole panel.
Yes, it is.
Anybody know how many sets of footage there are of the 24-hour sun in the South Pole?
Lots.
What do it depend? Define a set. What metric? what subunits are in a set?
24 hours.
Oh,
So
they'll be
looking at
continuous.
time.
Yeah,
Yeah.
There'll be okay. So there'll be 200 sets then, I would imagine.
Well, a time lapse vision of showing full sun. Because we've got someone in the chat that reckons it's only been done once.
In the South Pole, it probably will have only been done once continuously because
Why? You know they have a station set up there.
Yeah, but no one thought, I know, for artistic, prowess, I'm going to track the sun on this mount and set it up to record it over X amount of time. It's like people filming plants grow. Yes, time lapse on plants. We didn't have that 60 years ago. But technology is so cheap, and setting it up now and the effort required is not a lot. And the same would be of the sun, and like the same with EQ mounts and stuff like that, I would imagine. So yeah, I wouldn't imagine a lot, because out of all the scientists go down there, they don't all think, oh Jesus, I'm going to get my own rotation of the sun.
Yeah, it just doesn't happen.
I actually have a feeling they may do it every year.
Dean, there's one thing I have to disagree with you on. Time lapses have always been easy to do,
Okay, let me rephrase that before you answer.
It's the high speed stuff that's difficult.
No. Let me.
You just fire your cine camera.
Whatever. I'm going to rephrase it. I'm going to correct myself. To perform, assemble, and distribute, time lapses have never been easy to form and distribute before, whereas now it is.
Aren't you just watching it?
Oh yeah.
Well, the distribution I might agree with, because you'd have to have some,
Yeah, and obviously that relates directly to the effort required. Am I going to do something where I can just show my friends and family that's going to take, days and days and days to do? Well, possibly not. But now with YouTube, Vimeo, and mass sharing sites, well, yeah, because it might earn me some revenue, or I'll get a lot more recognition for it.
So far, what I can find is there was one done in 2015, one done in 2016, one done in 2017, and one done in 2018.
This one was 2015. I haven't found another one yet. That's the only one I keep.
Yeah, that's one thing that my camera can do fairly well, is time lapse. It's not a photography camera, but it will record and encode time lapse video very nicely.
Yeah, I mean, cine cameras have always been an easy way of doing time lapse, because they generally have a big roll of film in them.
Yeah, I mean, to be honest, I did time lapse, but on my 5D Mark II when it first came out, and I just did it by saying take a photo every minute, but a full frame 21 megapixel photo every minute, and then just assembled that later on, and it was cool.
And I mean, assembling that in Premiere is a piece of wee-wee, isn't it? Because you just drop all couple of thousand images you've got into Premiere, and it'll drop them frame by frame into the timeline in the correct order for you.
The advantage about doing it with a Cine digital camera, though, is it will do the motion and lossless delta compression across all the images into a video. So rather than taking the same data for single images, you get like 1/12 the size because it's doing decent compression, lossless compression. So
especially if you happen to be shooting Canon RAW, 20 megabytes per frame.
I think mine was my 21 megapixel. I can't remember how big they used to be. They used to be 25.
I think that'll probably get up to about 30 meg. Yeah. My 15, depending on ISO and what's in the image, because Canon do use lossless compression on the RAW files. Run between.
I heard the question now. Oh,
20,
bless you, whoever that was.
It got bacon.
Sorry, that was me. I thought it was on. I thought it was on mute.
Who is blessing himself?
Yeah, well, it's not actually him, is it? The bless you thing is actually blessing this evil spirit that was escaping him twice for some reason. Yeah. I think that's where it comes from. But
because we don't want to catch the plague.
Yeah. All right, Alan. Here's an interesting thing. What is lossless compression then?
It's any compression algorithm that reduces the amount of data, reduces the amount of space required to store data.
Sorry. How does it do lossless compression?
I'm guessing it uses the LZW algorithm.
And what does that do to the color information, which is
nothing?
It actually, well, all right. What's it do? How does it compress? You know.
I mean, you could use zip compression. It doesn't really matter because you're just. Remember, a RAW file has no intrinsic color information in it.
Yeah, but what I'm saying is how does it compress and be lossless? Because it must be taking away something. What is it taking away?
Hey, keep us in suspense. Just tell us.
It's taking away repetition.
Yeah, it's taking away repetition. So.
And it's actually the same way. CompuServe did an amazing thing ages ago. So CompuServe were an ISP, but they realized early on that this JPEG format by the Joint Picture Experts Group was a bit shit, and it was heavy. And why, when they want to display loads of information, they wanted something that could control the palette and get rid of duplicate information. So what they did is they did what you call an index palette.
Yeah.
So every time the same shade, but every time the same shade of red was referenced in a pixel, that pixel was given an inherent reference to the color of another pixel or an index table. So the red, the actual R, G, and B values that represent that color was only ever stored once, and then indexed with a single integer for repointing later on. And that's the same concept as lossless compression, if anybody gave a shit.
Yeah, but actually there's lots of loss in that because there's only 256 bloody index locations.
Oh, no. Index palletization, you can have a palette of many colors. You're not limited to 256. On a CompuServe GIF, you were, yeah.
CompuServe chose to use 256. So that's all you get. But yeah, there's no reason to. But what you have to remember is that actually in a raw image file, there is no inherent color information.
No, but
there is no color information encoded in a raw file. It's just the fact that each pixel location was filtered through a different colored filter, which which allows you to then rebuild the color
Yeah, but those filter values are still stored that do represent what you call tone mapped values of that color spectrum. So yes and no. I'd have to disagree with you a little bit there. The data that is there is interpreted as color, but it's interpreted as what you call tone map variance color, which means you have the ability to shift it up and down while preserving the latitude of either way, hence it being raw. But it's still, in the end result, that's part of a chrominance data set of that image, which is entirely representing color.
But it's not specifically encoded in the. In fact,
absolute values are not, no, but it is a color
you only have,
data set.
Because it's a color data set in so much as it's got each pixel location will vary. Neighboring pixel values should vary because they are being recorded through different colored filters, even if it is the same color that's being recorded at each sensor location.
Well, I like it. Jose just said Dean is a smart flat earther. Yes, I am. I love the flat earth. I can argue for the flat earth if I want, better than flat earthers.
I have a segue just on a little something that the flat earthers seem to bring up a lot is Airy's failure. Do they know why it's called Airy's failure?
It's because he succeeded, isn't it?
No, because he failed to find what he was looking for. Okay, the ether drag test. By means of a Woodfield telescope, Airy in 1871 looked for a change in stellar aberration through the refracting water due to an ether drag. Like all other ether drift experiments, he obtained a negative result.
It doesn't matter. The Earth is still flat because I want to believe that, and if I'll just read that as a success. The failure words mean nothing to me.
So negative is a positive?
No, I just nullify it.
How?
By ignorance. It's really simple. You can just.
No, I negate your ignorance with confidence.
I'm just going to stick my fingers in my ears and go, no.
Honestly, that is exactly what Ali did when someone said, because Ali came up with this this observation of the sun and the moon when he was in France. He was on a street and it was early, and he caught it and he says, and I'm pretty sure he said, this can't happen on a sphere Earth. Now, my first assertion would be, if I believed that statement was true and I was a flat earther, my immediate question would be, am I now the smartest person on the planet just to figure this out right now out of the billions of people that came before me? And obviously the common sense answer is, no, I'm fucking not. It doesn't matter who you are. You're probably not the smartest person on Earth. Although, being a flat earther, you probably think you are. But then he was shown with stellarium exactly that time, exactly that location, and it matched the sun and the moon observations exactly.
Oh, we spoke about this the other day.
Yeah, yet he just fails to acknowledge it. And to me, that sums up flat Earth. If you get evidence that does not confirm your absolute bias, it's just, no, it's not real. No, I'm off. See ya. Bye.
This is the one where you worked out the Earth was the one that was in the way.
Yeah, and this was where I pointed out that Sorry. This was a different one. This was Ali B in France taking a video, and it was on his channel. I don't know whether it still is. And he said it can't exist on a sphere Earth, the ball Earth destroyed or something. And all he's doing is it doesn't grasp the geometric reality of the sun is 90 plus million miles away and the moon is 250,000 miles away, and therefore this is real and can happen. And even when showed it in stellarium, someone at that point should say, oh, hang about, what I looked at and recorded and said
disproves the flat Earth actually proves it 100%. But they can't say that. None of them can, and that's just so intellectually dishonest.
Yeah. I mean, one of the things is that with those star trails I did, they've caught some satellites going over, and if you check in Stellarium shows you the satellites going over at the correct time.
Mm. Oh, wait a minute, Jose, Conspiracy Cats did a video of your interaction with Nathan and Quantum Eraser, and it was absolutely, it was so fucking funny. It was just really funny.
Sean G actually did caught that last night when we had Aaron on, and he was looking at Stellarium at the time, and the ISS was actually going over his sight line.
Oh, when we were talking about the position of the moon, so Aaron could go and see it.
Yeah, we told him to go outside and find it, and he lost it.
Yeah, and then
He
Stellarium saw the ISS go, whee!
Aaron lost the moon.
It was funny because it was actually over Africa at the
below
time.
the horizon, yeah.
Yeah.
I don't know about you guys, but I want to finish up because I've got to get up early in the morning.
Oh, all right.
Bloody Struth, yeah. Must be late over there.
Yeah, it's getting on to 1
Struth.
o'clock.
Yeah, all them East Coasters are all back to being 11 hours in front of us.
I'm not.
Yeah, you got to be different, don't you? Half hour.
Yeah, I've only got 10 and a half.
Yeah, you don't count anyway, demonic.
1, 2, something, 10. Is that right?
That's 1, 2, miss a few.
I
1,
did,
2, miss a few, 99, 100.
I just
Yeah,
as I was about to say I got to go. Mad B had to turn up, didn't he?
Oh,
I know. I sent him an invite earlier. You
Yeah,
just wake up.
Just before you stop, I've got a picture to share for you.
Okay.
All right. Just for a short time.
I like Gravity's pictures.
It must have been tasty.
Yeah.
Oh no!
I just got some frozen bacon out of the freezer. Thanks.
Did he actually piss in a bottle?
No, I showed the. I was looking at the video, and it was just him looking down at his desk for a few minutes.
Yeah, but it's. I have a feeling someone on the stream would have heard it because he's got a directional microphone, and considering the direction is in his direction, it would have picked it up.
Answer your question. No, I haven't just woke up. I feel like shit.
Oh no.
Oh, that makes two of you because Casual Spaceman was feeling a bit under the weather too.
Yeah, Casual Spaceman wasn't going too good.
Yeah, and I'm actually feeling better today, so that's nice. Maybe I've passed it around to everybody else.
Casual's struggling with his audio. He's not getting any sound coming through. And the launch is about 3 minutes to go.
Launch.
Anybody want to jump over and try and help him?
Hello, everyone, by the way. Hello, Alan. Glad to hear you're feeling better.
Hi, Mad.
Yeah,
even more so, imagine.
Oh, there's a woman.
Oh, no, I was just listening to Riley's stream just when he was looking down.
All right.
3 minutes to launch. What am I missing?
The Boeing pad abort thing.
The Boeing test.
Is Casual having troubles with sound?
Yeah, he's not getting any audio coming through at all.
Oh, no.
Sorry, Pip, you're not getting any audio through. What'd you say?
3.
So where's this launch on? What channel?
Well, I'm watching it on Red because it's working, and Red's on the telly and Casual Spaceman's got it. It'll probably be NASA or Space Videos or something.
I'll do a Google search.
I did the world. Yesterday.
Go to Red's reference channel. Sorry.
No, it's all right. When I came on yesterday, I wasted 8 hours of my day yesterday. I'm doing this machine learning training session at the moment, whereby I'm training a vision neural network to detect what objects are that it sees through a sensor. And I had to build a tool, a desktop tool, to be able to input correct data per image and do annotations and all this kind of stuff. And I did it. And I did an assumption where the annotation coordinates started at 0, 0, and that was the first coordinate, and then the last coordinate for the machine learning was obviously the extents of X and Y away from that. And I built this tool, and I've trained multiple things, multiple machine learning containers, and I tested them. And testing actually took about a day and a half, and I was getting really inaccurate results. I'm pointing at a light bulb, and it's saying this is a cable, and they're like, "Oh my god, this is so shit! It's not even usable." And I sat back down, and they're like, "No, this can't be right. It's because these results are so horrible. It's just failed." And I started reinvestigating, and I figured out that over the past 5 days, my tool, I've been writing the wrong coordinate system to define where objects are. So I've done all of this work. I've done 2 days. I've done 8 hours of machine learning training on a 24-core CPU thing that's flat out, along with days of setting it up, along with a day of testing it, and thinking, hang on, this is crap. And all because my coordinate system to start off with was wrong. It uses the center XY. It uses a center point origin rather than a top left.
Yeah, I was gonna say, did you not think about depth?
But yeah, it's just.
Have I got the right video?
It's wasted 4 days.
Yeah, Dean.
That's it.
Yeah, I just put it in the side chat.
Yeah,
in 1993, while I was learning to program in C, all our coursework was writing filters for edge finding and contrast.
Oh wow! Yeah,
and
nice,
stuff.
nice.
For machine vision, for machine vision and machine vision learning.
Yeah, that's exactly how a tensor path gets built up in machine learning. Is just multiple iterations of layers and decision trees that are just based on filtering the image to look at various different features and aspects.
Yeah,
but it hasn't changed any. It's just that onboard mobile computing devices are now that much more processor efficient and capable that you can do that real time now. Whereas back then it would have probably taken weeks.
We were writing the filters in C and running them on like 386 PCs with 4 megabytes of RAM.
Nice.
Wow, powerful.
Yeah. Oh, and running it on images that are like 512 by 512 pixels.
Wow.
And the big one, because we were running it on some stuff that was actually taken by the guy, that was, some of the images came off of the machine vision system that the guy who was teaching us the course was developing, because although he was teaching in the electronics department, he was a biologist. I still remember the most recognizable of the images was turned out, I didn't realize at the time, turned out to be a scan from the centerfold of the November 1973 Playboy.
So,
good
and it was used for nearly 30 years as one of the standard test images for all sorts of image processing systems.
Sorry, someone just said my name then.
Yeah, I was going to ask. Did you actually have to change the coordinate start numbers, or was it still 00?
Well, yeah. So the problem is, I've had to build an annotation and designation tool as a Mac desktop app to be able to input the data for all these image sets, to be able to tell, to be able to create the JSON or XML outputs, because it'll output. I'm making it to output multiple data sets for different machine learning systems.
PC master race. I'm sorry.
Yeah, but
no. Well,
anyway. No. This is for destination on an iOS device, and I'm sorry, but an iOS device in this day and age is so far in advance of Android or anything else that, and you need a Mac to do it. And the Mac operating system is so far ahead of Windows, it's not even funny. I have got a Windows VR gaming rig. I always use it for gaming and stuff, but that's all.
Of course
any serious
you do.
work I have to do on a
Are
any
you
serious
saying-
work I have to do on a
Are
Mac.
you saying Windows is only good for playing games?
Yes, I am indeed. That is exactly what I'm saying. In my world, relative to myself, that is exactly true.
I'd have thought you'd have been using something like Linux or Unix.
Well,
operating system.
Well, I am. I'm using Mac
Yeah,
OS,
'cause that's what
BSD
Mac OS.
Unix,
Yeah.
built by
Exactly.
Berkeley Systems. There you go. Just happens to have a very nice user interface wrapped over it. But this is, for all intents and purposes, the evolution of Unix by Berkeley Systems.
Have they got a delete button yet?
A delete button?
Yeah. I used to have a delete button what never worked.
Yeah, no, delete works fine. And has
Oh,
done ever since I've been using a Mac anyway.
All right. It's just that was always a joke that they had a delete button what never worked.
Yeah.
You know one of the minor annoying things I find with Apple, they won't make a flipping wireless keyboard with a numeric keypad on it.
Yeah.
And even though they make a 17-inch laptop, they won't put a numeric keypad on it.
What?
And they make £1,000 monitor stand now.
Can I've just taken this Australian company that I've agreed to work for and do this project. I am actually a staff member now there, but I just get to work at my home office because I'm not going to travel to Australia every day. One of the conditions of me joining was that they buy me a fully decked out brand new Mac Pro when it gets released. And I've been on the edge of my seat now for a month and a half waiting for Apple to release the Mac Pro because I've got it sat there waiting to be bought.
Have you heard the rumor?
What?
There's a problem with the Mac Pro.
They've
run into a glitch prior to manufacture. Yep.
No.
Yeah.
Is
I saw it on
that a
Forbes.
rumor or is it confirmed?
Nah. Well, it was an article in Forbes that they were saying something. There was a problem with integration of the software into the system.
I don't get that because
that's all it said. It didn't say.
You see, the problem is with a rumor that's non-specific.
Mm.
I don't shove any. I don't. All these rumors that say, rumored the next MacBook could have an escape key. That's not a rumor. That's just a statement of a probability that no one knows the fucking answer to. That's ridiculous.
And they probably charge you extra for it.
Yeah. No, I'm hoping. Well, the thing is, FCC they've just done a filing of FCC distribution and computing device over in the States for the Mac Pro in the last week and a half.
Oh, they must have worked it out then.
Yeah, so my guess is it's for
ready for
very
production.
Imminent. Yeah, it's very, very imminent distribution. This would be because for an FCC, once you get to the FCC stage, it's about distribution. It's not about production. It would be very unlikely not to get production due to no one would delay manufacturing a product.
Oh no, they'd still manufacture it. It's just whether or not they put the system on it or not.
Oh no, but yeah, the Mac operating system and that should be at the moment. I've got the 24-thread, the 12-core Mac Pro 2013, and it sat underneath my aircon in my office because I just doing this machine learning. It's just at 100% all the time, and with this new Mac Pro, it can be up to 7 times quicker, which I absolutely need that as quickly as possible. It turns my 6,000 iterations, rather than taking 8 hours, to taking 2 or taking 1. And that is something that I'm doing 20, 30 times a week.
Why don't they build you a tower?
Why don't you get an Epic Pro? I mean, Epic 64 core.
Money.
Because it wouldn't be a Mac. Oh no, the Mac Pro is going to be £17,000.
Yeah.
So probably about $20,000. But
Overpriced.
no, yeah, because I want a pipeline and a tool chain set up to use Create ML. Now, Create ML is a UI wraparound for Apple's own Core ML training set. So it's not like a distributed tool set. So something like, if I was using something like Chewy Create, which is a universal thing that I could run on Linux, I could run on Windows, I could run on anything because it's Python based, then yes, I could do that. But I'm wanting an entire Mac tool chain, because the one thing that I get out of it is on the new iPhone 11 Pro, on the chip, there are dedicated machine learning cores. And they are dedicated for me to use to do on-device retraining. So normally a machine learning container is this fixed thing that you send out, and you'd have to send it back to a cloud system or a big distributed computing system to be able to retrain, to then push an update out to a device to say, hey, here's some new shit. Whereas if I do it through this tool chain, I can have on-device retraining and then a Delta system to merge them to others. So if let's say I go out and add A to it on one device, it can actually in the background, without doing anything to the user. Yeah. Well, it can retrain it. Now, it might take an hour to retrain it, but there's no effect to hardly any effect to battery and no effect to user on an iPhone 11 Pro Max. Yeah. And if I do it through the Core ML, Create ML, and iOS tool chain, as well as OS 10, obviously, then I can have that with Chewy Create, creating the ML container. I can actually have that. So I need the Mac thing, because the product that I'm actually developing is very dependent on it being able to be updated by users.
How about a Hackintosh?
All right, guys, I'm going to drop. I'll see you later.
See you then.
Yes, see you later then.
Yeah, I'm finishing up.
I built a Hackintosh. I built 2 Hackintoshes actually, and yes,
cool.
performance price wise, brilliant. I even wrote a kernel extension versioning tool in case, when I was putting in custom kernel extensions to get things to work, if it ever died, I could just have a command line rollback to the previous version. I actually wrote that. I called it SR Tools, I think it was, and it was on Tony Mac and all that kind of stuff. And I was into Hackintosh, but when I started having a serious career in enterprise software, it's like, I can't afford anything to go wrong. I can't afford an update coming out. I can't afford Xcode not being able to work and me not being able to fix it. The downtime that it may cause me far outweigh price-wise the justification to buy, to spend £10,000 on a Mac. It just dwarfs it.
Yeah, actually, that brings me to a couple of things. One thing is, I have so much trouble trying to explain to members of my family how you have to get on board with cloud computing, because it's the freaking future, and you're going to have no choice soon. You're going to have to do it. I mean, people already use it with Google Drive.
Well, Google Photos, yes. Google Drive is just cloud. Well, you can call it cloud-based storage. Yeah,
it is.
But I mean, it's not cloud computing. It's just cloud-based. Well, it's just external storage.
Yeah, but it's
cloud storage is no different to me renting. I rent servers at one-on-one hosting, so
but it's still
I could call them
part
cloud
of the infrastructure. It's still part of the same infrastructure.
But I mean, cloud computing is like using an EC2 instance on AWS that can scale to do the machine learning, which is what we do sometimes.
Stingray, is it fact that they actually made a quantum computer?
Yes.
That is
IBM,
true,
yes. Yeah.
Oh, good, yeah.
And for 2 years they've been saying, please, they can't tax it to capacity, and I think based on their actions, they're running out of computing tasks to take advantage of it, which is why they put out so much public information, release so much public API and compute access to it as well, for people to be able to do their own tasks or solve problems.
Did they use a graphene core for it or not?
I actually don't know the specifics of the hardware, to be honest.
Oh,
I just know that ages. Yeah. No.
Yeah, I was sort of reading up there talking about going to vacuum.
Yeah.
Vacuum tubes for the next
Yeah.
processors. Yeah. That'd be interesting to see what happens in the next 2 or 3 years, because it's getting really, really exciting.
Oh yeah, quantum computing for I mean, quantum computing for machine learning is a no-brainer. It actually is a no-brainer.
Yeah.
Because and people don't realize that it's not a case that, so let's say I do a 6,000 iteration training container, which means it looks at every single image and compares it and runs 6,000 nodes and divergences on what it actually is, storing data sets for it, but for each one. What people don't realize is the reason why it's doing that is the units involved. It needs 6,000 to get to be semi-accurate.
Yeah.
And people think, oh, that 6,000 will be done really quickly on a quantum computer. Well, no, it won't, and it doesn't have to. It can do 600, but because of the accuracy that you can now get, you can do something 1,000 times more accurate in 100th of the time, because you're only doing 100th of the operations that you'd need to.
Have you heard the new Cray computer they're building?
I have not, no.
11,864, 64-core EPIC chips.
Nice.
Yeah, well, what I heard about, if they started using graphene, it means they could stack. Inside the chip. So you could have your 8 cores, and you could stack another 8 on top of that, and another 8 on top of that, and another 8 on top of that. And
do you want to know? Do you want to know an interesting thing? I thought when they, because I had 2 generations of Mac Pro previous to the trash can that I've got, so I had the big grill ones as well, but I had 2 of them. And when the 2013 Mac Pro was coming out, I was a bit pissed off because I'm also a graphic 3D artist, that you can't upgrade the graphics cards or use NVIDIA, which was a bit of an ass, but I got one anyway. But what I thought when they were coming out, because of their design and their single sort of like sphere and single fan, is I thought Apple was going to do something amazing. I thought what they were going to do is either with a cable or with nothing but a gravity connection, make it so that you could stack them on top of each other to have a parallel parallel multiplied computing device. So if I wanted twice the power, I could just go get another one and stack it, because they looked stackable. And then that didn't happen. And then they brought out the refreshed Mac Mini, and I looked at it, and the first thing that I saw was a stack of them, and I thought, oh my God, they've gone and done it. They've done it now with the Mac Mini. You could just go out and buy like 20 Mac Minis and have them in this stack and have this huge computing device.
Yeah.
And then they didn't. And it's like, when is someone going to bring out, we've now got with Thunderbolt 3 enough bandwidth to have, let's say, a quad Thunderbolt 3 connection would be enough bandwidth to have a parallel computing device. So you could just get 2 devices and say, there you go, now it's twice as powerful.
And you just have to put one cable to the other.
Yeah.
Wow.
And off you go.
Yeah, a quad channel Thunderbolt would be no different to direct memory access speeds or CPU bus speeds on board. So it's like, obviously there would be a tiny bit of latency, but from a computational standpoint, it's latency versus bandwidth. If you're going to download a huge movie, you don't actually care that whether it takes 100 milliseconds for circuit round time or 1,000 milliseconds. When you're downloading billions of gigabytes, it's going to take that amount of time. You want bandwidth over circuit latency. So
would you need 32 threads to be able to keep that connection stable?
Would I need what, sorry?
32 threads instead of 24 like most of them use?
No, it's not about. Well, a thread is just something that can run in a linear processing sense across a CPU. So if I had two of the ones that I've got and I could connect them, I'd have 48 threads that could run simultaneously off 12 cores, of 24 cores.
24 cores, yeah.
Or do Crays, which is going to have 1.5 million threads. They step always.
Yeah, I ain't got that amount of money to spend, to be honest. Yeah.
This is fine as long as what you're computing is parallelizable, isn't it?
Yes. I mean, to some extent, you can do distributed or deferred processing on a lot of things as well. But then you run into concurrency issues with processing tasks. But it's not out of the question in machine learning because in data sets that you're processing, it's like, let's say I've got 10,000 individual things where each one of those individual things needs a set of 6,000 things to run on it. Then that's the poster child for that kind of thing.
For parallelization.
Yeah.
I remember doing transmission line matrix modeling, and you'd think that would be, you'd think, a big grid of nodes that you're going to run computations on each node, that would be parallelizable, but it's not because
you run into acyclic data dependency issues with that kind of stuff.
Yeah, because you actually have to know. You kind of have to know what the nodes next to you are doing.
That now the program. This is interesting. You find this interesting, Alan. That program that I used to demonstrate flat Earth and built my flat Earth modeling, that I'm actually an instructor in. It's called Maya. It uses the definition of what Maya is when someone asks me is it's not a 3D program. It's actually a bidirectional dual pass evaluation dependency graphing system that's acyclic.
I'm glad you said that because I fully understand every word of that.
So, but the point there is, Alan, it does exactly what you said. What it does is it fires. It's just like neuron connections. It fires across a node and then returns that value, but then can fire back down that node to the next, and then pass it back. And it's a continuous and asymmetrical flow of data through this graphing system that just all works because it's always aware, and it's all, it's an amazing system. There's patents for it, which is just astonishing.
Okay, guys. I'd like to keep going all night about all this, but I'm going to end the stream now. So say good night to everybody.
Yeah.
Good night, everybody.
Good night, everybody.
See you later.
Yeah. Night.